This conference will now be recorded.
So, a very good morning, afternoon, or evening to one and all. So, as I welcome one and all for the day 2 session of today's webinar, and as I could find some of you are new today, so let me just give a brief introduction about the GoToMeetings app before we start our sessions. And yes, so here on the GoToMeetings app or the web page that you're using right now, when you move your cursor, you can find four buttons in the bottom center with mic, camera, screen, and leave. So for the mic, you can click on that to mute and unmute. And while others are giving their presentations, I request you all to please stay muted so that the speakers do not get disturbed or distracted with the noise that you might create. So, and the second option will be camera. You can use this button to share or unshare the web camera. If you have the option to share the webcam, you can do it, and it's completely of your choice and there's no compulsion. And in case if you face any network issue, I request you all to please do not share your camera because your network might get disconnected. So the next option will be the screen, and you can use this button to share your screen, and this is the important part. So during your presentation, after I call your name, I'll be giving you the permission to share your screen, and once that is done, you can then click on screen button and you will receive a pop-up window asking your permission to share the screen. So the last option will be leave. So you can use this button to leave this session. And on the top center, you can find the options to change your display settings. And at the top right corner, you will find three icons, that is people, chat, settings. So in the chat option, you can use this to chat with me or and send any messages or any queries without disturbing the audience. And for the settings, you can use the settings button to check for the settings of your speakers, microphone, camera, and etc. So as mentioned, I once again request you all to stay muted during the presentations. And if you're having any questions, you can ask all of your questions at the end of each session, or you can also send your questions through the chat box, and at end of each and every session, your questions will be answered. And before you start your presentation, I really request you to just give us a brief introduction about yourself so that even others will get to know about you virtually. And thank you all for joining today, and now let's start with our sessions. So we have our first speaker for today, that is by Dr. Stephen Salder from University of Edinburgh, United Kingdom. So we have his slideshow already ready. So yes, Dr. Stephen, you can go ahead. Thank you.
Good morning, and thank you for turning up so early, people in America. The key, my mouse isn't going down. Can't go to the next slide. What's happened?
Oh, you can actually use enter.
Well, it seems to have done that. Maybe it was inactive. Okay, it's bypassed. The problem we have at the moment is that the world is retaining 1.7 watts per square meter too much. And the mean solar input is 340 watts per square meter, which is very conveniently leaving a problem of just 0.5%. So what we need to do is to try and find a way to reduce the world annual solar energy input by just 0.5%. And to give you a feeling for how much that is, if you look down, there's a little black dot down at the bottom right, and that is the total world energy consumption in all forms. So this means that we don't need to make a very large reduction in the world solar input to solve the problem. Now, this is a lovely diagram from NASA showing how the world solar, this average of 340, how this varies through the year. We've got months, June and December up to here, and with latitude. And a lot of people are a bit surprised to see that there's actually more solar energy going into the South Pole in December than there is into the equator. And this suggests that maybe anything that's being done wants to be done in the highest power input. So maybe there's something that's moving between here and here. And the reason, of course, for all this, everybody knows this, is this Keeling curve. And what I've done is plotted against the Keeling curve against the dates of all the various COPs. And you can see the size of the reduction in CO2 COP by COP, and it's not actually very encouraging. The most worrying thing is that we're getting a lot of heat coming into the high latitudes, the Arctic ice, which is going to let more solar energy in if the ice goes in direct and the sun can go directly into water. There's also a lot of more methane in the permafrost in this area here in Canada and Siberia. And there's other things that are happening where as the ice melts in Greenland, it's exposing all the historical soot and ash and all that stuff from different places. There's melt ponds here which are much better at absorbing the solar energy. So we've got a whole lot of very nasty positive feedbacks. You can see the lovely curve here by Lee Robinson. The years are going from 1979 clockwise around here, 1985 and so on. The different colors are months of the year, and the radial distance from the center of this diagram to a different month or different year is the volume of ice in the Arctic in thousands of cubic kilometers. So you can see there's this death spiral coming down here. There's lots of people predicting what's going to happen. This is a history of predictions of the IPCC for the ice. And the blue thing here is the range of estimates of different models. The black is the mean of them. But the actual reality is this red one here. So we don't have a great deal of confidence in the IPCC. Okay, so the problem then is how to do some reflection. And one of the things that reflects solar energy is clouds. And this chap here, Sean Toomey, was able to get an airplane, and he could fly around over the tops of clouds with an exposure meter to measure how much solar energy was coming down from above. And then he could point it downwards and measure how much was coming up from the clouds. And he could also fly into the clouds and scoop up drops of the clouds and measure how many there were per cubic centimeter and how big they were. And the result of all his work was to show that the reflectivity of clouds depends on the size distribution of the drops. And there's a bit of algebra that comes out of it. A is albedo, this is what everybody else calls reflectivity. This depends on the depth of the cloud in meters times the liquid water content in cubic centimeters of liquid water per cubic meter of air, and the number of cloud drops in a cubic centimeter n there. And this is the distillation, and it works from about reflectivity of 25 to 75%. So clouds have a very wide range, right down to when we say the dark storm clouds are gathering. And you can rearrange that if you want to say how many nuclei do you want to get your choice of albedo. And this is what an engineer would want to have. You can plot all these those equations in these graphs here. The vertical axis is reflectivity, perfectly reflecting here, or a dead black thing here. The x-axis is the number of cloud drops per cubic centimeter. And the curves here are for different depths of clouds, running from a rather thin one, 100 meters to 1,000 meters, which is a bit on the thick side. Same axes here, but now we're fixing a 300 meter depth of cloud, and we're varying the liquid water content from 0.1 milliliters up to 1 milliliter per cubic meter of air. And you'll notice that these are really rather similar. And we can see what's happening if we plot this graph on top, where you can pick any curve you want. Let's say we pick this red one here, and we start at this point here with a rather low concentration of just 10 nuclei per cubic centimeter, rather wispy thin cloud. But we double it to here, and then go back to the previous curve. And you can see how that's changed the reflector. We double it again here and go back to the red curve, double it again, go back to the red curve, double it again, go back to the red curve. Okay, so you'll notice that these steps are all fairly similar, and this is telling us that what matters is not really the cloud thickness or the liquid water content, but what really matters is the number per cubic centimeter. And over most of this diagram here, you can say that doubling the nuclei concentration or the cloud drop concentration is going to increase your reflectivity by about 5%. All right. Remember, we only wanted to have a 0.5% change. Okay, so that's rather promising. We can also show this diagram here, which is putting all of Toomey's work onto one slide, which is really rather nice. We've got vertical axes here of, this one is cloud top albedo, and then you also have top of the atmosphere albedo, which is of course affected by what's being changed between the top of the atmosphere and the clouds. Or we can have up here is the forcing in watts per square meter. Remember that our problem is about 1.7 watts per square meter now. And to use this diagram, you pick any change you want. Let's say we want to go to 0.5. Yeah, you pick this point here, and you travel along the horizontal line until you get to the slope line, and then you drop down to get the relative number density of change that you need. So this is saying you need to have double the number to get the 5% change. Okay, now this is all instrument work with airplanes and in measuring light and scooping drops, but you can prove that it's really true by getting a jar of glass balls and changing the size of them. Here, these are 4 millimeters and those are 40 micron. And so that's really robust physics. It's been replicated by a chap called Andrew Ackerman. And I think we all accept that now. It's not a computer model, it's a real instrument measurement. This chap here, John Latham, thought that we could use this Toomey effect by spraying submicron drops of filtered seawater into the marine boundary layer and letting the Toomey effect make the clouds whiter and reflect the energy. Got a paper in 1990, yeah. And he was very amazed to find out how little water you needed to do this. I've got here the spray rates for different reflected powers. So I drew this in when it was 1.6. It's now a bit higher than that. So we should. And this is saying that to correct the damage you've done up to now, you need to spray nearly 10 cubic meters of water a second as 0.8 micron diameter drops. And that's really not a very difficult, well, I'll moderate that. First thing we need to know is how many drops there are now if we want to double them. And here's some maps of the cloud condensation nuclei concentration. This is in per cubic centimeter. And you see there's lots of sea area, this dark blue, where it's about 20 per cubic centimeter. Up here, it's 100 or so. So we're wasting our time to try to double 100, but it's much easier to double 10 or 20. Well, at that time, I was working on an idea to try and make the sea evaporate faster, and I was trying to get a Duras egg beater turbine to centrifuge water out and spray like that. John Latham heard about this, and he phoned me up and said, could I make the spray for his project? And I said, yeah, I think I can do that. It's much, much harder than I thought it was going to be, because I was trying to make 30 micron drops, and he wanted 0.8 of a micron. And the reason for this is shown by work by a chap called Coalesce, who was interested in how a drop could be formed. You need to have a relative humidity a bit over 100%, a bit over, but you also need a tiny little seed to start it growing on. It could be smoke or dust or anything, but the weight of the seed that you need to use depends on its chemical nature. And this is showing relative humidity in the vertical direction here. And this is the growth of the size of water condensing on a nucleus. And it has to get over a hump like this in order to slide down and grow up to a full-size drop. And the size that John Latham wants to have is this one here, which has got 10 to the minus 14 grams of sodium chloride. And there is a slight hump here. You can just see it about here. If we can get up to this relative humidity, 100 point, I think it's 03, then it really starts growing to that limit. But if we're smaller than that, it doesn't grow at all. It gets stuck somewhere down here. The size will vary according to whether it's condensing or evaporating. And what we want to do is to have a liquid water drop of 0.8 micron, which if it dried completely would leave a salt residue about 200 nanometers. We found that this seems to be a very long-lived thing. This is a map of the scavenging of nuclear fallout when we're worried about bombs. And our liquid spray and our partly evaporated and our dry crust are all in what's called the green field gap. There's some work suggesting that if we had coarser, bigger things, it would warm, and also if we had smaller things, we can warm. The way we want to make a drop is done by work of a chap called Lord Rayleigh back in 1878. He's got a lovely photograph. Imagine photography in 1878. He's got a jet of water coming in from the left here, and it's beginning to grow these bulges, and they're getting more and more severe, and they're breaking up into drops like that. And the way we want to do it is to have a silicon wafer, an 8-inch diameter silicon wafer, 200 millimeters, here, clamped between two grids, and we want to pump very well filtered salt water into them here, and they would go through a whole bunch of nozzles and make the spray, just like Lord Rayleigh was doing. If you don't believe this, you can check it out in your shower in the morning. Put your finger near the shower head and then move it along the jet, and you'll feel it smooth to start with, and you'll feel it pulsing. We also want to be able to take fresh water backwards, pumped in here, and going backwards and pumped out here to clean any clogging. This is a graph showing what pressures we need for different drop diameters. We want about 80 bar pressure. And this is showing how the variation of nuclei concentration is from different ocean regions and different months of the year. So this is pointing to the fact that we might need to move around. We want some energy to make the spray, and we want to move around. So we think looking at sailing ships, this is the Cutty Sark, a sort of pinnacle of technical achievement of sailing vessels. But it's very difficult to make that controlled remotely. We want to have these things unmanned, and we want to use a different kind of sail, which is a rotor rather than a textile cloth sail. And this is a drawing by a chap called von Prandtl, who you've probably heard of. And it's comparing the sailing rig of a ship with another way of propulsion, which is these rotors here. If you have these rotors that are spinning, they do exactly the same job as sails. And he tested this by having a race between one hull with conventional sails and an identical sister hull with the rotors. And there is the sister hull coming. He had a race from the Baltic to Edinburgh, which is a familiar shape here. And this is it in 1926. He got his orders for lots more. Everyone was very excited. And then in the 1929 depression came along, and all but one were cancelled. But they are being put onto ships now. This is a real one here with 4 rotors. And what we wanted to do, this was one of the early ideas where we had a ship like this with rotors spinning to drive it through the water, energy generating from these turbines down here. And we then found that there's a very big drag on this. So we changed the design to getting the force for the drop generation done by moving hydrofoils up and down. We changed the pitch of the hydrofoil. If we increase the pitch, this goes up. Similarly, this one comes down. So we can use that pitch flapping motion to generate energy, and we have the opposite phases of it on the aft ones. So this was a later design. That's going up, that one's going down, and that one's going down, and the one behind is going up. And there is a very chap having a lot of fun. But you see the size of these hydrofoils here, how tiny they are compared with the buoyancy that you'd be using. This is the present design. We've got hydraulic rams here, which are pumping high pressure oil. We're converting the oil pressures to a water pressure, and we're squirting the spray out. We spray it out horizontally, but because it evaporates, it cools the air, then the air comes down. The air can't get into the sea, so this spreads out as a layer of cold spray and air over the sea, and that being in contact with the sea warms it up. And maybe that nighttime when the air is colder, it goes shooting up into the boundary layer. We're not trying to shoot it up ourselves, we're letting turbulence do it all. That's showing the level of mechanical detail. You won't see this at all on PowerPoint, but we've got all the equipment for making spray and storing energy and smoothing things, and even an emergency diesel engine over here. And these are all in quick change canisters. So the design is very well advanced. This is showing you, the red dots here are showing you all the estimates made for the total amount of salt being thrown up from waves. And these are in gigatons here. And these are years in which the observation was made. And the average of them, it must be a very difficult observation to make, which explains all the scatter. The average of them is that blue circle. And we want to spray water, which is represented by the thickening of this black line here. All right, so there's vast amounts of spray being thrown up from waves now of a wide range of different sizes. Quite a lot will fall back quickly, and all we want to do is to pick exactly the sweet spot, the right size for Coalesce nucleation to keep him happy. And that's about 1,000 spray vessels, which is more than we think we need, working at full power, which they won't always be doing, is 160th down, 160 times down on what's already going up there. So it's not the mass of salt that puts going up, it's the number of successful nucleations. This is some work done in Norway, where they increased the initial number of nuclei from what it was to by an increase of 50%. And you can see it's doing very nice cooling up here, 4 degrees up in the north where we really want it badly. But it's also increasing the precipitation in the Sahara and South Africa and Australia and Mexico and good places like that. Another thing we can do is to cool the surface water to moderate hurricanes. This is showing the intensity of hurricanes up here and the sea surface temperature here. You need to have other things as well to make a hurricane, but you do have to have this warm surface water. So we could get the countries in the Caribbean to agree on a pattern of sea surface temperatures that would moderate hurricanes in that area and minimize the damage. They start over, usually they start over on the African side and get more and more severe as they come across. And this is the pattern of growth of lots of different hurricanes. Same sort of thing is happening around in the Philippines and the Pacific. And what we want to do is to say, tell us what temperature you want, and you pay us according to how close we can get that. We won't ever promise you'll never have another category 5 because we can't risk being sued. So what we do is we have these vessels cruising around here, measuring the temperature all through the year, starting in perhaps at the end of the hurricane season in November, and trying to get this back to the right, our target temperatures in June for the next year. This is what was happening at the same time as in Kenya and Australia. And this is from the Australian Bureau of Meteorology. They're showing that the temperature difference across the Indian Ocean is what's controlling rain or floods. And what we could do is to have spray vessels cruising, a flotilla of them cruising around the Indian Ocean and moving east or west according to what people wanted in either country. That would be a nice sort of experiment to do. This is how many spray vessels you'd need for different jobs, El Niños or Arctic ice or sea level rise. we could reverse sea level rise, taking 20 years to do it with just 400 vessels, but doing it anywhere in the world will do the cooling job there. What's it going to cost? Well, you lose your job if you tell what the real cost of a manufactured product is. So the only way we can do it at this stage is to try and look around for the nearest similar sort of weight of something and the nearest similar power of something that's made in similar sort of numbers in a similar kind of environment, and then compare them. And there aren't many things that are like it. The only thing I can find is the corvettes that were made for the Royal Navy in 1940, and that's a Canadian one that cost £60,000 in 1940. And this is quite a bit heavier than our boats, and it's quite a lot more power. We just want 3 kilowatts or 2 megawatts. But I think it's fair to do index linking for that. And you need to multiply money by a factor of about 50. I got those numbers from an indexing. So it's probably going to cost about £3 million, maybe $4 million. And if I wanted to get 800 of them, I'd have to borrow 2.4 billion. And if you want to borrow that amount of money and do a bit of maintenance, you have to pay about 10% of it a year. So it's going to cost 240 million pounds a year to own a world fleet to do all the things that you might want to do. And that's rather a nice number, because the police got an estimate for the security at COP26 was 250 million. So it's going to be cheaper than the security for COP. That's my 25 minutes. And thank you for getting up so early in the morning.
Thank you for your presentation, Dr. Stephen. So, yeah, do we have any questions?
It's too early in the morning for questions.
Oh, yes. So,
right, I will be talking a little bit more about it later this afternoon. You've given me another slot, and I'll be talking about how to get an everywhere to everywhere transfer function of the technology. When you do a change in one place, it can change things in the other side of the world. We know that this happens, but we don't know enough about how it happens and why it happens and what the effects would be. But I think that we will be able to find out if we can use an electronics idea in climate models. So if you can bear to hear any more about it, it'll be sometime this afternoon.
Yes, sure, definitely. We'll be waiting for that presentation. So I guess right now there are no questions. So thanks a lot, Doctor, for your time and your presentation. It was informative and interesting too, and easily understandable. So thanks for that. So let's move on to the next presentation now. So that will be by Dr. Beatriz Ledesma and Dr. Silvia Romanciero from University of Extremadura, Spain. So I have the presentation with me online, like in my system. So let me just play that.
Thank you very much.
Yes, I hope the presentation is visible to everyone. Yes.
Thank you very much. Hello, everybody. My name is Beatriz Ledesma, and I'm going to present my work, whose title is Converting a Process Waste into a Process Improver, Recirculation of Water During Hydrothermal Carbonization. Skip, please. Thank you. My research has been done in the frame of the research group I work at, that is Geiger Group, which is in English, it means Group for the Integral Use of Biomass and Renewable Energies. We work with different renewable energies, but in particular, my research is focused on biomass. I work with different thermochemical processes, such as gasification, pyrolysis, and combustion. And also, during last years, we have focused on hydrothermal carbonization. We work with different lignocellulosic biomasses, as well as other types of biomass, which are more difficult to use, such as sludge or tires, for example, from plastics. Next, please. As we all know, biomass is one of the possibilities we can use for the transition to a more decarbonized society. As advantages, it has it has one very important advantage, that is that it is spread out, so it is not just in particular countries, as it happens with fossil fuels. We can also see as a very important advantage that we can transform biomass to different aggregate phases, such as solid, liquid, or gases. And on another hand, depending on the thermochemical process we use, we can make use of biomass to produce heat or electricity, or even to extract some valuable materials. In general, for when the aim of using biomass is the solid carbon that we can get, in general, we have been using pyrolysis during many years. As we all know, pyrolysis is the thermal treatment of a material under inert conditions. Because of pyrolysis, in general, most of the oxygen and hydrogen from the material, in this case biomass, will be gone, and also part of the carbon. As a result, we will have a final solid material, which is usually called biochar. A biochar is a char, a carbon material with enhanced heating value. During last years, we have seen the wet pyrolysis, also called hydrothermal carbonization, as an alternative to this traditional pyrolysis. With this HTC, hydrothermal carbonization, we use water under mild conditions, let's say between 150 and 250, to degrade biomass so that it will dense its content in carbon. We can skip. Hydrothermal carbonization is a very simple process in which you just have to add biomass into water and heat it up to a temperature of about 200, 250, and then a complex interplay of reactions will happen so that the liquid phase will become rich in many organic substances, and the solid phase will become more carbonaceous. The char we obtain from HTC is called hydrochar and can be used then, as we have already proven, into an activated carbon by means of activation processes. It can be used directly in the soil as soil amendment, and many other uses. Skip, please. As I have said, we can find many different compounds in the liquid phase. These compounds are somehow interesting because some of them are very valuable in the market. We have made a presentation yesterday about this. We can mention here furfural, 5-hydroxymethylfurfural, or levulinic acid, for example. But all these compounds in the liquid phase will also react by means of different combination reactions, polymerization, aromatization, and will somehow be forming another hydrochar. We say that after hydrothermal carbonization, biomass is degraded and we get a carbon at the end that is really composed of two carbons. The carbon that comes from the biomass and the carbon that comes from the combination of liquid fragments of biomass. another very interesting advantage of this process I always mention is that because water is a reactive and water is also a product of the reaction, all the biomasses that have a high humidity content are welcome for this process, what does not happen in the case of traditional pyrolysis. Opening the broad margins between different biomasses can also give rise to the use of many materials, like, for example, waste from the agro-industrial uses, or even aquatic species, etc. Skip. Thank you. Well, apart from all these advantages, we have to say that there is still a limitation on the real implementation at big scale of hydrothermal carbonization. As we have said, what happens in the liquid is very complex, and there are many gaps in the research at this point. We know that some of the compounds we get in the liquid can be useful in the industry, but some of them are also limiting the use of hydrothermal carbonization because of their toxicity. Here we can mention, for example, furans or polyphenols. So using HTC is a promising method to give a use to waste, but in the way we are also generating a liquid that could be potentially toxic. Some researchers are now focused on the liquid because they want to find a way of making this liquid more environmental friendly, while some other researchers are focusing on the possibility of using this liquid for further processes. So recycling this water, using processed water for next hydrothermal carbonization runs. This is what we have done in this work. Next. Thank you. In this way, in this work, we plan to use the processing water of hydrothermal carbonization for next processes in different cycles. We have tested up to 5 cycles, and we have seen how the solid yield of the final product is modified, and also we have investigated if this final product has different features. Next, please. The biomass we have used in this case are pine cones. The research was made as a collaboration between the University of Gavs in Tunisia and the University of Extremadura in Spain. Pines are a very abundant biomass in Tunis, and they want to find uses for this material. So, well, before using this biomass for experiments, we made crushing and grinding processes to get an homogeneous particle size between 1.2 and 1.6 millimeters. Next, please. After having the biomass, we made our hydrothermal carbonization experiments in one autoclave from Digestec in the brand Berghoff. And well, after each process that we made during different times, 3 and 20 hours and different temperatures, 200 and 240, we always filtrated the solid hydrochar. That solid hydrochar was our product, and then we would characterize it by means of elemental analysis, thermogravimetric analysis, high heating value, and also surface analysis, not only by micrography, but also by spectroscopy. Next, the liquid from this filtration process was used for next hydrothermal carbonization processes. In the figure, we can see how we proceed. For example, in the first reaction, we use 100 milliliters of water. After filtrating, we always lose a little fraction of liquid because of evaporation, managing of equipments, etc. So in next hydrothermal carbonization processes, we always dilute it up to the same 100 millimeters volume. Skip, please. Here we start discussing our results. In the first way, in the figure, we can see how the solid yield of hydrochars changed for each run. The first reactions are for 3 hours, and in them we can see for the different cycles that in all cases a higher temperature involved a lower solid yield. In the figure, as it is described, the discontinuous line is always representing 200 temperature runs. So if you see, the discontinuous points are always higher in the scale than the continuous ones. Using a higher temperature has been proven to be a very interesting way of densifying biomass. So when we find a lower solid yield, like in our case here for 240, we would expect a bigger carbon densification for these materials. Then if we increase the time, we can see that in general, bigger time also involves a lower solid yield. So we are enhancing the reactions. In this figure, it's interesting to see that the slope of the different lines, the discontinuous and the continuous, are not the same. So we can see that there is an interaction between the properties. Using a higher temperature will have a bigger and more intense effect of time. So far, we can say that using processing water will not have a bad effect on solid yield. We will not lose a final mass in the carbon. The next thing will be, what about the quality? So we are saving money, we are saving energy, and we are saving water. But these hydrochars that even have higher solid yield, do they have the same properties? Are they equally valid? Next. Here we can see, I will pass fast in the slide because this is something we are going to see later again. But here we can see that along the different cycles, we can get a bigger fixation of carbon for cycles that are after the first one. That means that if we use just water in a hydrothermal carbonization process, we will densify the carbon content of biomass. But if we use not clean water, but processing water, the final hydrochar will have a bigger amount of carbon. This is very positive, and this is also consistent with the effect of combination reactions between the molecules that were already present in the liquid. We have not said before that during hydrothermal carbonization, we always have a drop in the pH. So this will also be positive because it will enhance the degradation reactions if you use processing water. We can see this effect in carbon, and we can see that the effect for the other elements is not as important. Also, the effect in carbon was found in the high heating value. Next. Here we have tried to understand if using processing water will have an effect on the thermal resistance of our hydrochars. And we can see that, yes, there is an effect. The TG and DTG profiles have been plotted for the different cycles for the different temperatures. In general, the most important thing we can say from these pictures is that the black line is in both cases the line that represents the experiment with clean water, so the first run, while the colors always represent the cycles, 1, 2nd, 3rd. For the sake of brevity, we have just included some of them, but in all cases, we can see that the peaks are moved towards lower temperature values. So our material has somehow a bigger vulnerability towards the heating process. And this is more evident if we use lower temperatures. This could be related to the fact that this recombination of surface compounds will be more stronger. It will be stronger when we use 240. And because of this, these elements are harder to degrade at this temperature. Skip, please. Thank you. Finally, we were also interested in investigating if the surface functionalities and the surface morphologies of our hydrochars will be significantly affected by the cyclic use of processing water. In all cases, and all this has been published in a paper, I have references along the presentation, but in all cases, the important thing we have seen is that the first run, the one that we make with clean water, is always different than the following ones. But from the first cycle to the fifth cycle, we don't find very remarkable effects. It's true that using processing water will make the hydrochar less hydrophobic. For example, we will find some additional functionalities, and we will also see a little growth on the microspheres of the hydrochars. This is what we can conclude from this slide. Next, please. And well, as concluding remarks, we can say that using processing water is very positive because we are saving water. We are saving water that, on the other hand, was not very friendly to the environment. If this water is hot, we are also saving energy. And at the end, we have demonstrated that it will not have a bad effect on the final quantity of hydrochar we get, but also on the final properties of these hydrochars. We see that it can even improve the kinetics of the process because we are starting from water that was already acidic. So it will make the process more efficient. And in general, some of the compounds that are absorbed from the liquid phase make the final hydrochar to have a greater high heating value. With regards to the features like carbon content, thermal behavior, or surface functionalities, we see that the big difference is always found in the first cycle. Slide, please. Next. And finally, I would like to thank you for your attention. We are Guideberg Group. We are located in Extremadura in southern Spain. And well, we are open to any question or any suggestion you want to make. Thank you very much.
Okay then.
Thank you for your presentation, Dr. Sylvia Roman. So yeah, do we have any questions?
Yeah, definitely. Yeah, please stay connected.
Your voice is not audible, Dr. Helmi.
Yeah, please stay connected. So once I call your name,
yes,
you
please
can start
continue
your
with that.
presentation.
I have two questions actually. So
Okay.
Thank you very much, Sylvia, for this interesting presentation. First, I'm very interested in this presentation because I myself come from Tunisia. Basically, I live in Qatar, but so first is about the biomass that you use. You know, the region that you are collaborating with, I mean, Gabes University. It's a famous region for palm tree production, and they have a lot of palm waste, you know, in terms of leaves, you know, and fruits. So it makes sense that you, for example, you valorize better their waste. I mean, they have a huge amount of biomass. I mean, date palm biomass to be valorized because, you know, pine cones, they come from the north, from the pine forest, you know, they're located in the northern mountain area of Atlas region. So this is my first remark. Second, just to ask you about the properties of the char that you produce. I mean, in case that you use actually cone pine biomass, right? So
Yes.
was there any study conducted to compare, for example, the properties of biochar and hydrochar produced from these pine cones? And what would be the effect on soil amendment afterwards, soil properties? Because I use a lot of biochars for amending soils in terms of, let's say, soil physical-chemical properties, water retention, and let's say carbon content. So these are my two, questions or remarks.
Okay, thank you very much. Regarding the first question, the pine cones we have used, they came from Tunisia. This was the result of a research stay of one student from Tunisia that came to our university. She was here for 6 months and she brought her own materials. And they came from the region. So I guess they are from the north. I can give you more details if you want by email, because I can ask her. Okay. And regarding the second question, we have compared, because pyrolysis is the parallel process to wet pyrolysis. So every time we make hydrochars, we like to compare how the corresponding pyrochars will be, the pyrochars from pyrolysis. The use of hydrochars in soil amendment processes is something we are also very interested in, and we have started investigating that. And what we found is that hydrochars have these surface compounds that are already there, and they could be harmful for the soil. So we have post-treated these hydrochars. We have subjected them to washing with hot water, with acetic acid, and we have found some improvements. We are still working on that, because at the moment, hydrochars are good because they have more nutrients, they have more nitrogen, phosphorus for soil, but they are also toxic because of these phenolic compounds in the surface. So we are trying to find a compromise situation.
And actually, one of the main characteristics or like properties of chars in general is absorption capacity. I mean, maybe biochar has higher absorption capacity or absorption sites than the hydrochar. You know, so this another, maybe the hydrochar are more rich in nutrients, but on the same time, sometimes we look more for like absorption capacity, especially cation exchange capacity, which is like on the long term is one of the basic soil improvement characteristics. You know, so it's not always a matter of nutrients, because in general, chars are not rich. I mean, as like manure or sewage sludge, like fresh materials. But sometimes we look more to the physical properties rather than nutrient content. Okay.
Yes, I absolutely agree with you.
Thank you very much.
It's a challenging thing using hydrochars for this. Thank you.
Gracias.
Shukran.
Shukran. Thank you. Thank you. Thank you very much.
Thank you for your present. So do we have any other questions? Okay, I guess there are no questions. So thanks a lot for your presentation and your time.
Thank you. Bye.
So let's move on to our next, bye-bye. So let's move on to our next presentation, and that will be from Dr. Amrita Preetham from IIT Delhi, India. So,
yes, ma'am. Ma'am, still a student, not a doctor title I have. So,
okay,
yeah.
so Ms. Amrita, could you please click on the screen button to share your screen with us?
Yeah.
Your screen is visible, and also your PowerPoint presentation.
Okay. Is it visible properly, right?
Yes, it is.
Okay. So good morning, all of you. This is Rita Preetham from IIT Delhi. Today I'm going to present on the topic recovery of valuable materials from waste electronics using ethanol as a supercritical solvent. So I will start with the basic definition of e-waste. My slides are not moving properly. I'm unable to move my slides.
Please try clicking on enter. Yeah, I guess it's
Yeah, it's
changing now.
visible. Yeah.
Yeah,
So
it is.
we will start with the basic definition of e-waste. E-waste is any electrical or electronics appliance that has been discarded by its owner without the intention of its reuse. So there are total 6 categories of e-waste that are lamps, large equipments, small IT equipments, small equipments, and temperature exchange equipments, which are shown here in the figure. Uh, so the worldwide e-waste flow in terms of its generation and consumption has been shown here, uh, with the most recent and official report, which is Global Waste Monitor 2020. It has been found that in 2019 the world generated around 53.6 million metric ton of e-waste with an average of 7.3 kg per capita, and unfortunately we saw that only 17.4% of e-waste produced is being recycled everywhere. Asia generate the highest amount of e-waste, followed by America, then uh, uh, America, then Europe, Africa, and in last the Oceania. Uh, Europe recycled the maximum amount of e-waste produced. So the contamination of e-waste is been done in various ways, like by landfilling, unregulated accumulation, or incineration, which directly or indirectly affect the environment by contaminating soil, land, water, and eventually it affects the health of uh, human, animals, plant, and disturb the overall ecosystem. So recycling e-waste is both it involves both challenges and opportunities. In terms of challenges, it involves by causing lots of air pollution, water pollution, or land pollution by unsystematic disposal of it. And in opportunity, it involves, if we recycle the e-waste properly, we can we can generate large amount of resource, and we can reduce the burden on the earth by its ore. So the composition of e-waste mostly involves iron and steel, uh, with the average weight percent of 47.9%, followed by flame retardant plastics and non-flame retardant plastic with the combined share of 20.6. The major polymers present in it are polyethylene, polyacetate, epoxy resins, and it also a rich source of various base metal and precious metal, glass, and others. So the overall motivation of e-waste recycle is to degrade or decompose the non-biodegradable plastic present in it, such as brominated epoxy resins, or and the and it at the same time it also contain a large amount of various base metal or precious metal, so which can be systematically recycled. And by doing both of them, we can cut the greenhouse gas levels, and 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 by recycling the e-waste, we can generate more amount of employment. So for my PhD topic, I have chosen random access memory as my field, because it is a rich source of metals such as copper, silver, gold, tin, nickel, and it also contained the non-biodegradable brominated epoxy resin. If it is untreated, it can certainly leach the soil or can cause various type of pollution. So for the characterization of my e-waste, I have did a FTIR analysis and TGA analysis, and I found that it contains the various amount of organic compounds present in it, such as alkenes, alkanes, or aromatic stretch, aromatic ring, and several halogenated compounds. And from the TGA analysis, it has been found that the most of the organic present in it is being decomposed within the temperature range of 250 to 450 degree Celsius. Beyond 450 degree Celsius, no significant degradation is being recorded. So to treat the non-metallic fraction of the e-waste present, I have taken supercritical fluid technology, which involves the utilization of supercritical fluids. They are the class of fluids which exist beyond the critical point, where it is hard to distinguish between the liquid and gas phase of the compound. It has a property between liquid and gaseous compound, so it will be beneficial to dissolve the organics present in it. So, so the benefits of taking supercritical fluid technology is that it involves the milder temperature as compared to other conventional processes such as pyrolysis or pyrometallurgy, which involves the temperature more than 500 degree Celsius. Secondly, it generates no secondary pollution or harmful gases such as NOx or soot. It also it also helps to generate the halogenated free liquid oil product, and it provide a promising reaction medium for the process. So this is the overall flow diagram of my process. We first introduce the RAM as feed with the ethanol as solvent in the high pressure reactor at a specified temperature and pressure. Uh, After the reaction, the solid part and the liquid mixture is being separated. The solid product is being analyzed with the help of ICP-MS or MPAS. The liquid product is being analyzed with the help of GCMS, and the solvent is being efficiently recovered with the help of rotary evaporator. And this is the experimental setup for the process. So I have varied temperature, time, and solid liquid ratio, gram per ml, for the overall process. And by in increasing temperature, I found that the liquid yield of product is being increased from up to around 80%. The possible reason behind the same could be temperature provide high energy to dissociate the bond present in it. From the time effect, we found that from 30 minute to 60 minute, the liquid yield product is being increased. The possible reason for the same is probably the prolonged exposure of the supercritical phase, which helps to efficient the liquid oil present in it. Uh, Increasing temperature beyond 60 minutes has not any significant yield is been recorded. For solid liquid ratio, 1 is to 30 solid liquid ratio is being found optimal. The possible reason could be that methanol provide a homogeneous provide a homogeneous phase, which helps to reduce the interfacial mass transfer limitation and helps to dissolve the organics present in it. The final pressure has been set at 90 bar. The air is purged with the help of nitrogen, and around around 85% of the ethanol is being recovered after the reaction with the help of rotary evaporator. So these are some basic um, compounds found in the liquid oil products such as phenol, cyclohexane, 1-hexanol. It can be further separated with the help of distillation or any other separation process, and can be used as a raw material in any chemical plant or industry. The solid product is being analyzed with the help of MPES, which works similar as ICP-MS does. So it has been found that after the supercritical ethanol treatment, the solid fraction of metal is being efficiently enriched. Uh, um, for example, the copper is the highest copper is the most abundant element present in the waste ram, which is being enriched from 27 weight percent to 36 weight percent, and the color of the solid product has been changed to black from its original gray color, and it also enriched the precious metal such as gold, silver present in it. So the possible mechanism for the whole process could be the free radical uh, mechanism. The supercritical solvent provide a homogeneous phase which helps to reduce the interfacial mass transfer limitation, and which helps to dissolve the organic efficiently. The reaction could be probably the free radical mechanism, in which the energy supplied is more than the dissociation energy of the molecule. The initial decomposition method is done from the comparatively weaker bond, and which helps to form some small monomers. So the key observation is that the supercritical ethanol has the potential to efficiently degrade the organics present in it. It also helps to provide the halogenated free liquid product, and it also efficiently enrich the metal present in it, which can be further utilized to leach the metal, and leaching of the metal and can be recovered from the process such as electrodeposition or adsorption. So the social impact of the overall process is that by recycling e-waste in a sustainable or systematically or sustainable manner, we can make the world better place to live by controlling the pollution, by making plastic free oceans, uh, by generating uh, resources in a sustainable manner. So this is my overall presentation. Thank you for your patience and time. If you have any question, please ask. Otherwise,
Yes, thank you for your presentation, Dr. Amrita. So yeah, do we have any questions? Any questions?
Yeah, hello, Dr. Namita.
hello.
Yes, I guess there are no questions. So
Yeah,
Okay.
am I
yes,
talking to Dr.
thanks a lot
Namita?
for your presentation and your time.
Okay. Thank you, ma'am. Yes.
Thank you. So now let's move on to our next presentation.
Yeah, please join.
That is by Dr. Raina Ijaz from University of Poonch Rawalaka in Pakistan. So let me make you the presenter. Yeah.
Yeah, it is around.
Dr. Raina, could you please click on the
Yeah, hello, I'm here.
screen button? Yes. Could you please click on the screen button?
After this, your talk will be there. That's the reason we are going ahead of our schedule. Please join so that we can announce your name. Yeah, right now you can see the program. Dr. Gyan will come next up talk is going on. After the Dr. Dinar's presentation is there. After that, yours will be.
Yes, your screen is visible to us.
Yes. Yes.
Yeah, is it visible to you?
Yes, your screen is visible to us.
Okay, is that visible?
Yes, your presentation is also visible to us.
Sorry, it's like. Is this visible to you? Yeah, it's okay now?
Yes, it's perfect. You can start with your presentation.
No, sorry. I just have to, switch off my phone. Sorry.
That's okay.
Okay, hello everyone, good afternoon. I'm going to present my half of the research work that is related to my project. It's just my little efforts toward this conference, and thank you, Jessica, for arranging such a great conference. And it's really good to know all of you, all of the researchers from the different countries to know about their scientific work. Well, I'm Raina, Faculty of Agriculture, University of Punj, Pakistan. The topic of my presentation is the tomato synthetic, sorry, please.
You could click on enter button or any arrow keys to change your slides.
Yeah, there is a okay. Analysis of the tomato synthetic seed for the development of an optimized encapsulation system. Sorry. I don't know, there's a problem I'm facing.
Can I know what is the issue that you're facing so that I can help you out with that?
I'm just continuously trying to put next slides, but I don't know what's wrong with that.
Or could you please check on clicking arrow marks, the arrow keys? Is that not done?
No. You mean at the left side, the three buttons click? No.
Okay, you're having that GoToMeetings notification bar. Is that what you're talking about?
Yeah, because I'm going to just, put in other slides. It's not going to be happen.
Oh, you will find two arrow marks facing each other. Could you please click on that so that the notification bar will vanish?
Could I send to you?
Yeah, sure. Let me just put on my email ID.
Yeah, please.
Yes. I have sent my email ID. Could you please just send that to me?
Okay. Okay, I sent you.
Okay, let me just check.
Yeah, sure. Did you get it?
Not yet. I'm just waiting for your email. As that might be a bigger file, it might take some time. Yeah, I got it.
Okay, thank
I'm
you.
just downloading it. I hope you can see the screen, and do let me know when to change the slide so that I can do that for you.
Okay, yeah, sure. Thank you so much. So topic of my presentation is analysis of the tomato synthetic seeds for the development of an optimized encapsulation system. Well, next please. Next. Hello.
You want me to skip this slide too?
Yeah. Hello. Could you please listen to me?
Yes, I can. I am on the second slide, that is synthetic seeds or artificial seeds. So do you
Yeah,
want
it's
me to
okay.
skip this one? Yeah.
No. So please stay on that. As in fact, in synthetic seed production is an innovative technology with preference over traditional seed propagations and the micropropagation for the production and delivery of clonal plantlets. So this technique provides a method to distribute plants and meet international quarantine requirements. So our focus is that through the biotechnological tools, that is the tissue culture laser technology, that is one of the most important application of modern horticulture, extensively used for plant propagation. In vitro culture is used in tomato for different biotechnological applications with the production of virus-free plants. Next, please. So we choose the tomato crop, white tomato, because it is one of the most important vegetable crops grown widely across the world, and it is also one of the plant species which is broadly studied with a marvelous amount of the public data across the research community. So it is grown in almost all over the countries of the world. Conventionally, tomato is propagated by seed and then transplanted into the field. And the different reports have been studied, like cultivated tomatoes suffer from many diseases, like causing fusarium wilt, bacterial canker, root knot, and so many diseases that is caused by bacteria, fungi, viruses, and nematodes. So these studies also, these diseases also contributes to the reduction of hybrid seed recovery from the field. Next, please. Synseed. Synseeds are the encapsulated somatic embryos, shoot bird cell aggregates, or any other tissue that can be used for sowing as a seed or that possess the ability to convert into the plant under in vitro or ex vitro conditions, and that can retain this potential also after storage. The production of synseeds is specially used for plants which do not produce viable seeds. It represents a method to propagate these plants. Next, please. Actually, the aim of this work Because as I told you, like the tomato crops and other different solanaceous crops, they are suffer from different diseases. And I just mentioned that tissue culture is one of the most important application of the modern horticulture that is extensively used for plant propagations. So our aim of the objective of this research work is to evaluate the effect of storage conditions and antibiotics on the growth ability of the synthetic seeds, to verify the possibility to store same seeds of tomato for the different the time periods, and this study will lead to the commercial application of the same seed technologies like germplasm storage and its exchange across the globe. Next, please. Need for artificial seeds. Why we need artificial seeds make a promising techniques for the propagation of plants, non-seed producing plants, polyploids with elite traits, and plant line with the problems in seed propagation. Being clonal in nature, the techniques cut short laborious selection procedure of the conventional recombination breeding. Like this diagram represents that the seed structures matrix like the plant propagules and the hard covering layers of the capsules that is covered with the sodium alginate solutions. In the next slides I will show you. Please, next. Methods for making artificial seeds. These are methods like first we have to follow the establishment of Coalesce culture. Here is the right side of the diagram represents induction of the somatic embryogenesis, and the third one is the maturation of the somatic embryos, and the last one is like encapsulation of the somatic embryos. So we have to follow these steps step by step. Next. Plant materials which are used in this, that is the explants were excised from in vitro culture of tomato, maintained on the MS mediums, that is with 2% sucrose, and these all the procedures we have to follow like to grow the seeds. And then we have formed with use the 3% sodium alginate solutions, and also with the calcium chloride for the complexation. Both the sodium alginate and the calcium chloride solutions were sterilized by autoclaving for the 15 minutes, and explants were submerged in sodium alginate solutions for 2 minutes. Next, please. The steps which are involved in the scheme used for the encapsulation, germination, and maturation of the tomato microshoots that are shown in the table. This one, like first we used sodium alginate, and then with the gelatin, that's useful hydrogel for the encapsulations with the different concentrations. Next. So encapsulation with the sodium alginate solutions, these are the uninodal skirting with the root primordia that is encapsulated with the sodium alginate solutions mixed with a different concentration of the antibiotics, including both fungicide. As I told you already, the encapsulation was followed by the complexation with 1.1% like calcium chloride enriched with the artificial endosperms composed of the MS medium. For the 35 minutes, the procedures we have followed, like after complexations, the alginate capsules were washed twice for 15 minutes to wash away excess calcium chloride each time with the autoclaved rinse solutions consisting of the artificial endosperms without any further additions. Next, please. And then, these are the steps we have to follow, like after encapsulations for employees to plant conveyance, greenhouse, and the field planting. Ex vitro acclimatization was achieved here by a simple procedure already proposed, like by a different one of the scientists simplified the acclimatization process. Plants were directly transferred to pots here, and containing house saving light intensity of that, and data recording with the in vivo survival percentage of the plantlets derived from the synthetic seeds. We have to follow all the steps. when we just going to put the seed in a process of acclimatization. Synthetic seed stores under cold storage conditions were better acclimatized and compared to those stores at a room storage temperatures. So furthermore, more plant regenerated from cold stored synthetic seeds resulted in a higher shoot length during acclimatization, and then those regenerated from stored ones. So this depicts that positively increased in success rate during hardening or acclimatizations of tomato. And these also demonstrate the possibility of the transfer of the exenic plant material from one country to another country in the form of the synth seeds. Next. Here are the findings. Like after this process of the encapsulation seed, we also check the storage time intervals. With the storage time intervals, that's also very important because it's a very critical factor for an exchange and preservation purpose, which determines the success of synthetic seed after after their transportation abroad. So therefore, appropriate storage conditions and definite storage periods required to maintain viability during exchange of germplasm. That is very important for the synthetic seed technology and its commercial application. So in addition, development of appropriate storage techniques is also obligatory for successful conveyance of the synth seed of clonal germplasm of elite and endangered cultivars in the near future. So, however, various pathogens like to reduce the viability of the synth seed. So we just checked like the 0, 30, 60, and the 19 to 120 days of the storage time intervals. We checked the different time intervals because various pathogens reduce the viability of synth seed. So it is very important the use of the antibiotics in the encapsulation matrix is recommended to increase the viability to optimum storage conditions. That is, the antibiotics which are used belongs to a broader group of like antimicrobial compounds that is used to treat infection used by microorganisms, including fungi and the protozoa. And these are just a picture which is represent the encapsulation synth seeds. Next, please. And we used next. Here is the uninodal skirting. As I told you, like with the root primordia encapsulated with the sodium arsenate solutions, 0.5% with the different concentration of antibiotics and the bactericide and the fungicide, as mentioned in the previous slides, to enhance the viability percentage of the synthetic seed. So these are the steps one by one which are followed in encapsulation of the synth seeds. Next, please. This studies confirms the incorporation of inorganic and organic nutrient sources in synth seed is necessary to aid in the survival and the vigor of stored propagule survival, and the conversion of unstored synth seed was improved with the nutrient supplements. So the reason for the reduction, like in the different parameters we studied, that was demonstrated and the reporting already, as the storage interval increased, the viability of encapsulated cutting decreases. So moreover, the lack of the reserve and the loss of the viability of the encapsulated cuttings might be the driving factor for the decreasing the root length or the shoot length. And the second one, we just find out that the high mortality and the low conversion of tomato synth seed stores for 15 and 30 days demonstrated a strong incompatibility with these environments. Similarly, the low survivability of conversion ex vitro of tomato aloe bead synth seed also indicate negative sensitivity to encapsulation. Next. The best results were obtained when synth seeds were stored at 4 degrees centigrade and germinated on MS medium. Regenerated plantlets were successfully established in potting soil. Further, with sporting or conclusions reported, as it was obvious from the previous work that the root formation and elongation is energy requiring process, while encapsulated cuttings are deprived of a sufficient energy. Hence, it can be hypothesized that unavailability of the energy providing compound during the storage interval leads towards poor root growth and less root length. This research demonstrates a possibility of the transfer of organic plant material from one country to another country in the form of the synthetic seeds. So further studies can be carried out on the basis of these findings. Next, thank you. Is there any question, please?
Do we have any questions? Do we have any questions about the presentation or any comments that you'd like to make? Okay, I guess there are no questions. So thank you. Thanks a lot for your presentation.
Yeah, thank you so much.
So let's move on to our next presentation then. So we have our next presentation by Dr. Nabila El Alami from Maulay Ismail University, Morocco. So let me just make you the presenter. Yes. So Dr. Nabila, could you please click on the screen button to share your screen with us? Dr. Nabila, I'm sorry, your voice is not audible to us. Your voice is actually not audible to us, Dr. Nabila. The video is fine. Your voice is not audible. Could you please try to disconnect your headphones and everything? Your laptop voice is audible, but not your voice. I'm sorry, still your voice is not audible. Could you please check the settings at the top right corner because your voice is not audible. Dr. Nabila, could you let me know if you are using your desktop or a laptop? Could you please send us a message in the chat box if you are using a desktop or a laptop?
मेल बटे से बकर आइकन क्या क्लिक
Or could you try to install GoToMeetings app through the Play Store in your mobile, and with that you will be audible to us. Maybe there is a problem with your system's audio problem or something. Maybe using your mobile phone, could you try to install GoToMeetings app?
Yeah, thank you, Dr. Mohammed Hussain.
Dr. Nabila, are you online or are you trying to download the install the GoToMeetings app in your mobile? Could you please type a message because I'm not able to hear you anything because could you please type us a message so that we can listen to you? Or could you please send me your mobile number in a private chat so that I'll just call you to explain and we can move forward with the other poster presentations now. Only if you can type us a message, I can help you out here. Could you please type me a message?
United. But
If you are okay that I can proceed further with the next presentations, at least let me know so that in the meantime we can solve the issue. But I'm not able to hear from you anything, so I'm waiting for your reply.
రిజిస్ట్రేషన్ పోర్టల్ ఉంటుంది కదా అందులో లేదు ఆ డీటెయిల్సే లేదు ఆన్లైన్ రిజిస్టర్ నబిలా ఎల్ఎల్ అని 99 Morocco.
I'm just trying to help Dr. Nabila through phone call, so I request you all to please be patient. Thank you for it. Oh, we are actually trying to help Dr. Nabila, but as she said that she could only understand French very well. So, do we have any speaker who can speak French? Okay, I guess there is no one who could speak French. So, okay, I will help her out maybe in the background. So I guess it's better we just move on with our next presentations. And Dr. Nabila, I will come back to you in some time. So let's move on with the poster presentations now. So for the first poster presentation, we have Dr. Anak Mail from TT Plus SA, Poland. So I'm just making you the presenter and I request you to click on the screen button to share your screen with us.
Hello.
Dr. Anakmel, I'm sorry if you're speaking, but could you please unmute your mic?
Sorry, could you repeat because I didn't understand you?
Oh, okay. Till now, we actually couldn't hear you well. So that's the reason I said I wanted you to unmute your mic. So, yes. So, for you all to check the poster, you can use the zoom in and zoom out buttons that is just present at the left center, sorry, right center. That is, take a screenshot, detach cameras, plus and minus. So you can just use that button to zoom in and zoom out. So do we, as you have already checked with those poster presentations, so do we have any doubts? Any questions or any doubts? Okay, I guess there are no questions. So let's move on to our next. Thank you for your presentation, Dr. Anakmel. So yeah, let's go on to our next presentation then. So for the next presentation, we have Dr. Jingjing Tao from University of Göttingen, Germany. Could you please click on the screen button, Dr. Jingjing Tao?
Hello, can you hear me?
Yes, we can hear you.
Could you see my screen?
Yes, yes, we can see your screen.
So now you can see the poster of me.
Yes, yes.
Okay. Good afternoon, everyone. I'm come from Göttingen University. I'm very happy to share our work here in the form of a poster. Let me give a brief introduction to our work. Soil acidification has increasingly become an issue due to the excessive use of natural fertilizers in agro-ecosystem. So we did an incubation experiment to investigate the effects of natural fertilizers on acidification and to estimate the CO2 emission. We added 14C calcium carbonate to the soil. From the 14C radioactivity, we can see the CO2 not only come from organic carbon but also from inorganic carbon. Because the ammonium we can have nitrification. The process will reduce H+. And the calcium carbonate can buffer the acidification by the dissolve of itself. And finally, it could emit CO2. So it's an interesting result. So the SSC also is a CO2 source. So we should choose the proper fertilizers based on soil condition and plant demand. It's necessary to decrease the contribution of SSC in CO2 emission and save the barriers of soil. So it's my main results. Welcome to ask questions. Thank you.
So maybe you could just take your time to just check out the poster presentation for the next 2 minutes. And for any questions, please feel free to ask for any comments too. So do we have any questions? Okay, I guess there are no questions. So let's just move on to our next presentation then. Thank you, Dr. Jinjintao, for your presentation. So yes, let's move on to our next presentation. And for the next presentation, we have Dr. Jemima Mariano from St. Teresa College, India.
Hello, Dr. Namita.
Mary, are you online?
Yes. Please share your screen with us. Okay.
Jemima Mary Anil from St. Teresa College, India. Are you online?
Yes, yes. You can hear me?
Yes, I can hear you.
Yeah,
So,
yeah, I'm present.
yeah.
Wait. You can see now?
Yes, your screen is also visible to us.
Yes,
So
you are
yes, we can start with your
from your phone.
presentation now.
Wait. You can see it, right?
Yes, your screen is visible.
Okay. Respected panel of experts, I'm Jemima Marianan, pursuing PG Diploma in Fashion Designing from St. Teresa's College, Kerala, India. So this project has been done as a part of my graduate studies during 2019-20. As textile waste is generated day by day, we thought of doing the project focusing on consumer preference for upcycled textile products. So as you see, textiles occupy a very important place in our present day society as it is one of the essential necessity of mankind. And the textile industry is one of the most polluting industry, and it is estimated like it's the third most polluting industry. And the fabric waste has become a significant problem for fashion industry. So the practical solution of consuming the waste back into the production process is not widely pursued. So, hence, the fashion consumers and stakeholders need to evaluate the present status quo according to the principles of sustainability and circular economy. So, our objective was to investigate the quantum of textile waste generated as tailoring units at local level, which comes under pre-consumer waste and the mode of disposal. So, the attempt was to cycle the waste into useful product and to assess their impact on the consumers. So the methodology was the sample for the study consisted of tailoring shops, owners, and tailors operating from their homes. And we conducted an interview, and the amount of textile waste created on a weekly basis. And the schedule included 7 questions. The textile waste was collected from shop and tailoring unit in-house, and useful, innovative products were created. And the product developed from the textile waste was assessed by the creativity, utility, and aesthetic appearance in a 4-point scale, that is excellent, good, fair, and poor. And these are the products. You can see it on the right side. Okay, and the products were evaluated based on creativity, utility, and aesthetic appearance. So, based on creativity, we found out that product 4, product 6, and product 12 was rated excellent. That is the product and product based on utility. We found out that product 11 and 12 and product 7 and product 1 were rated excellent. And based on the aesthetic appearance, the product 6 and product 7, then product 11 was rated excellent. And let me tell you the products. The product 1 was pencil pouch. Then we made wall hanging, and product
Then flower vase, table sheet, photo frame, slipper, accessories and jewelry, girl's frock, fabric braided belt, and fabric diary cover. And then a fancy bag. And we found out that 85% of the tailoring unit discarded the waste by either burning them or selling them to vendors. And the evaluation of product assessed by the consumer indicated that no products were rated poor. And mainly the bag, table sheet, slipper, and pencil pouch were rated excellent for its creativity. And for aesthetic appearance, slipper and hair accessories were rated excellent. And upcycling can be taken as a cottage industry, creating job opportunity to many, thereby helping in waste management and for economic growth. And that's it. Thank you. Can you hear me? Hello?
Yes, so let's just check the maybe a poster of a few minutes and then we can go for the questions. Or in the meantime, if you're having any questions, you can just post it up.
Is it visible now?
Yes, you could actually zoom in and zoom out for any to see the
Okay.
poster clearly. So
Yeah.
yeah. So do we have any questions? Okay, I guess there are no questions. Anyways, thank you for your presentation. So with this, we have completed the poster presentation. So let me just go back to Dr. Nabila. Dr. Nabila, can you speak now? Let's just check if we can hear you out. I could see 2 logins from you, but I'm sorry I couldn't hear you well. Could you try to download your mobile app and speak through the phone? Because with the computer system, you will actually need a proper mic setting. Dr. Nabila, could you hear us well, or could you just send us a message if possible? Okay, I will try to contact Dr. Nabila through mobile once again. And in the meantime, as we have a lot of time for the next sessions, I guess it's better we just take a break. So let's just take a break for as per the schedule time. We will once again gather at 1:45 p.m. and then continue with the rest of the sessions. And by the time we'll see if Dr. Nabila will be able to resolve her issues, and then we can continue with the sessions. Thank you once again. We'll all meet up again at 1:45 p.m.
This conference will now be recorded.
So for the oral presentation, the next oral presentation, we have Dr. Derwell dos Santos Rosa from Universidade Federal do ABC, Brazil. So let me just make sure the presenter. So yes, Dr. Derwell, you can click on the screen button that's beside
Yes,
your mic and camera, so you'll be able to share your screen with us.
yes, I just share. Oh, yes, oh, here, but I need to choose the presentation, okay?
Yeah.
Okay, but I don't know how can I do it. Okay, just a second, sorry. I cross the share here, and the Google Meet ask you use some no. So you share my screen. I'm sharing my screen.
Okay, Abhi, it's actually not yet visible. So
No.
let me just check. No, not yet visible to us.
Oh my gosh.
Can I know which laptop you're using? If that's
Mac.
then you'll need. Oh yeah, you will need some extra system preferences that you need to give permissions for you to share the screen actually. Or maybe you could send your presentation to me to my email ID.
Yes, no
So,
problem. Okay, please. What putting
yeah, let me
in
just
share?
put a. Let
Putting
me
in
just put
share
my
and
email ID.
or in you? Yes.
Yeah.
Okay.
Here he's booking as per the rooming list till 17. So anyway, checkout is tomorrow. And you mentioned that
Yes, I have sent you the email ID. Please share your presentation to this so that I can share it on your behalf.
Thank you, Jessica.
अरे 17 checkout करना
second.
Sure.
I sent.
Okay, let me just check my email ID. Just give me a second. I'm just waiting for your email. Just give me some more time. Just 1 minute.
So sorry.
So I've got the mail and I'm just opening it. Just give me a second.
Thank you. Thank you very
Yes, so
much.
I guess the screen is visible. Yes, so we can proceed further with the presentation, doctor. And do let me know when to change the slide so that I'll do it on your behalf.
Thank you very much for your help me. Okay. And thank you. Firstly, I would like to thank you very much for the organization for this opportunity to stay here and to talk something about the opportunities and challenges of eucalyptus residues application in a pickering emulsion. So the next, I'm Dervaldo Santos Rosa, and this talk we prepared with my two students, PhD students, Alana Gabriele and Rafael Souza. As you know, I'm from Brazil, okay? I have been working and I live in São Paulo state, in the southwest of our country. And our university is located in two cities that the name is Santo André and São Bernardo do Campo. This region is so crowded because we are very close to São Paulo and city. Okay, the next is possible you show I show the next slide, please. Okay. So our mission is research and develop environmentally friendly and advanced materials. Focus, especially in my case, focused on polymeric materials, searching for several industrial processes, especially when we look for some residues. And today I will talk about the lignocellulose residues. The next. Our university, it is very new. It was founded in 2005. We have 2 campi, and our colleagues we have 100 our faculty holding PhD and professors, and we are a public university. It means the tuition is free and for students and Brazilian students and the students that goes abroad. So the next slide, please. Well, here you want some views of our 2 campi, and of course we have some accessibility and refugee and service, human rights, sport, recreation, and affirmative. So the next slide. Our institution goes to internationalization. So we have at the moment 1,400 it's closed students we sent abroad. So the next, please. This is one view. The next, please. One view over our lab. The next. And we have 189 labs. I'm chemistry, and since 1984, I have been working with and polymeric materials. At the moment, so next, please. I had, thank you. I had my master degree in chemistry at Unicamp, is an important university in Brazil. And we have a lot of research, and I have been working in 2 undergraduate programs, in science and environmental technology, and nanoscience and advanced materials. And I have been working in material engineering in undergraduate courses. The next, please. So, when I thinking in residues, special wood residues or something like that, we thinking in lignocellulose residues. It's possible to look at this and observe it has, and cellulose, lignin, and hemicellulose. So I have been working with a lot of residues from agricultural waste and forestal waste and industrial waste. The next, please. Well, I pay attention about residues, especially for using some special subject. I have been working with aerogel and using in water treatment and other application, a lot of application like mushing films, and that is possible to use in agriculture. And today I will talk about some Pickering emulsion. The next, please. Well, if you look at, pay attention to Web of Science, thank you. If you look at Web of Science and pay attention about the cellulose, at the moment, the number of the paper is increasing a lot. And the next, please. And we are looking for nanocellulose or microcellulose because it is biodegradability and biodegradable. It presents a low toxicity. It is biocompatible and renewable sources. So I think we need to think in life cycle assessment and picking some residues and produce some nanocellulose, sometimes to incorporate it in polymeric materials and to prepare some composites that it is biodegradable. And sometimes I using some composites like in mushing films in agriculture for to deliver some nutrients in soil, and sometimes using some other application. The next, please. Well, when you look at the eucalyptus, I think it's in here in Brazil, we have a lot. In Brazil, one of the largest eucalyptus producers in the world, around 40, 80 million tons per year. And this is, and we use it a lot of to produce some special in a oxy or something like that. But this process produce a lot of residues. The next, please. And the eucalyptus, if you look at the residues of the eucalyptus, it's possible to observe these residues has around 40, in general, of course, 40% of cellulose, 30% of lignin, and 30% of M-cellulose. The next. Well, it's possible to prepare some nanocellulose using some residues, and this nanocellulose, it's applied a lot of area, like hybrid materials, information technology, semiconductors, nanomembranes, and healthcare and other applications. We are pay attention about the packaging, and we studying a lot of packaging and water treatment, special and in hydrogel, and membranes. And we starting to some materials for some biomedical application. The next, please. Well, the new alternative when you look at the opportunity or challenge for to use nanocellulose is using to prepare some Pickering emulsion. That it is the main advantage is it's not necessary to use some surfactants to prepare these emulsions. The next, please. Okay, when you look at the Pickering emulsion, I think important to think that to have a good surface coverage in oil droplet and to have some formation of stable and three-dimensional network and to prevent the droplet from approaching, I think it's important to considering predominantly steric stabilization. For to do it, I think the key parameters, there's a lot of parameters that you need to think for in this process, like the size of the particle and the surface ruggedness, the wettability of the materials, the concentration of the nanoparticles, and all other structure and chemical and another and parameters. The next, please. So, and when you're considering some emission, there are colloidal dispersion in which the dispersed phase is constituted by small droplet and liquid distributed and in a vehicle in which is immiscible. There are formed by homogenization of two immiscible liquid phases in which one then disperses the other to form some small droplet. The next, please. Well, in this work today, and I use it, I will talk about the one essential oil. For few things in essential oil, this is a vegetable orange defined by a set of properties, some volatility, aroma, and flavor, insolubility, and high tendency to oxidation. According to International Organization for Standards, and the essential oil is a product prepared by distillation with water or steam, or by mechanical processing of citrus husk. So the next, please. Well, we have been working with a lot of essential oil, and usually I work with in it for two, and in this case, we prepare some Pickering emulsion for to use it and to antivirals and to bacterium, and so it's important to pay attention for two components, the family of components, phenylpropanoids and terpenoids. And that this is defense against the pathogen and sometimes like herbivores and to protect the herbivores or some microorganisms in general. The next, please. So the essential oil is a type of materials has a low solubility in water. It is organoleptic, tasty, and a little thermal stability. And the next, please. In this case, we prepared some an emulsion using Pickering, using some two contents of nanocellulose fibers. And in this case, we prepared using linalool, is an essential oil. And we prepare in 3 steps. Firstly, we put some soil in water, what soil? And nanofiber, okay? And we prepare testing. We made some experiment design and changing some the speed. In this case, we just show 2 speeds and 10,000 and 12,000 RPM. And we change here the concentration of essential oil. The next, please. If you observe, when you compare the stability under storage and if you compare half pi 0 0.5% of CNF or nanofiber of cellulose. And if you compare with 1% of nanofiber, it's possible, observe the next please, the 1% of nanocellulose is possible to stabilize more the emulsion. The next, please. Okay, the next. Okay, if you to understand the more stability of the emulsion, I think important you look at the morphology. The figure show illustrated that the droplet were encapsulated by the nanofibers, indicated that the CNF adsorption on the oil droplet surface. If you observe, increasing the concentration of the CNF increases the homogeneity of the three-dimensional network formed, in which the cell all showed a superimposed nanofibers and network structures on the surrounding aqueous phase, characteristic of the gel-like structures. The next, please. Well, as I said, the surface tension is so important. So when we look at the surface tension of when you use 1% of CNF with linalool oil, and we observe the surface tension around 32 millinewtons per meters. So this result obtained according U and Z indicated that the oil droplet were well covered by eucalyptus cellulose nanofibers, which can be attributed to the three-dimensional network that imprisoned the oil droplet within the nanostructure with the power stabilization capacity of the Pickering emulsion. The next, please. So I think important to understand this stabilization is important to look at the interaction of the oil and the nanocellulose. Okay, and the ethereal results show us the high stability between the oil and the eucalyptus nanofibers are the results of the chemical interaction between the molecules of the linalool and the nanocellulose, the both of which have free hydroxyl, and that which is capable and to interact between them. The next, please. And here today, I just to show the opportunities that is possible to use some residues from biomass, okay, and to prepare some Pickering emulsion. In these results that I shown the results of the linalool, okay, but we carry out other studies and using different oil from Amazon in forest, and we have here in Brazil and a lot of oils from Amazon region. So I have been studied it a lot. And here it's possible to show we also carry out using some nanocellulose from eucalyptus, and for the stabilization, the cinnamon oil. It's the other studies that we did. So unlike that was observed for linalool, there was no chemical bond with the essential oil. It is associated with the chemical structure of the oil. Of course, you know that sometimes some oils there's a lot aromatic rings and other components that is changing the stability. Okay, and this figure illustrated some stabilization of when using cinnamon. The next, please. Well, the important things that is necessary to talk is the application of the Pickering emulsion. Of course, the antimicrobial is important results, is one of important results that we have been, and so according to Zhang et al., cinnamon results in a several morphological destruction of the microbiorganisms, increasing the cell membrane permeability and causing leakage of the nucleic acid and protein. So in this figure, it's possible to observe some that emulsion show high antimicrobial activity due and cinnamaldehyde. The next, please. Okay. As conclusion, a Pickering emulsion stabilizer nanocellulose is possible to obtain a high stabilization power. Considering the essential oil, the stabilization effect is increasing the shelf life of products without losing and bioactivity properties, increasing the application of this emulsion, okay, using some residues of lignocellulose. The next, please. We are studying another oils and this and the next, please. Is possible to see other studies that we develop in our group, okay? And in this case, when I published in last year, the effect of essential oil chemical structure on Pickering emulsion stabilized with the cellulose nanofibers. And the next, please. Next, please. Yes. And the other is I published in cinnamon essential oil nanocellulose based in Pickering emulsion processing parameters. And you have in this paper it's possible you see in details all the studies of the parameters that we did to understand a little more how can I forming or stabilization the emulsion and the behavior of the antimicrobial activity. The next, please. And this in food packaging and shelf life, we put some application. We study starch-based film, and when you put some nanocellulose stabilizer in Pickering emulsion, contain different essential oil, this is possible to understand when you're changing the polymeric materials. So in this it's a very new paper that we published recently. Okay, with my colleague that I would like to thank you and the collaboration, Professor Sushanta Mitra from Waterloo University in Canada. Okay, the next, please. So I'd like to share my channel, of course, because I'm working and in some to do some scientific dissemination, because I think it is very important. I put in the chat. So if you have opportunity to share this, for me it's very important. And here this video, I share some information about natural fiber. The next, please. Thank you very much for your attention.
Yeah. Thank you for your presentation, Dr. Dowell. So yeah, do we have any questions? Okay, I guess there are no questions right now. So thank you for your presentation and your time. It was informative and interesting. So let's move on to our next presentation then. So
Thank you
for the
very
next
much.
presentation, yeah. So for the next presentation, we have Dr. Perfecto Barragan Pena from Tecnológico Nacional de Mexico or Instituto Tecnológico de Nogales, Mexico. So I have received your presentation, Dr. Perfecto. So would you like me to present it for you, or would you like to try it on your behalf first?
Thank you. Would you let me to try first, and afterward we see how it works?
Sure. I have already made you the presenter. Kindly click on the screen button so that you will be able to share your screen. Yeah, your screen is visible to us.
Okay, thank you very much.
Yes, we can proceed with the presentation. Thank you.
Thank you. Okay, good afternoon to everyone. Good morning from Mexico. I'm going to talk about the reuse of municipal wastewater from tertiary treatment to restore a wetland ecosystem at the Lisus watershed. We have seen that living in the northwest of Mexico in a semi-arid region is a real challenge to get some water resources. And we understand municipal wastewater can represent, if properly treated, a valuable source for different destinations and to a variety of purposes. Actually, water reclamation is excuse me, is something we can just deal with to derive an extra source to gain on water resources diverted from the biological cycle of water to anthropogenic uses. The use of this water contributes not only to the aquifer recharging, but to sustain a variety of flora and fauna. Wetlands are perhaps some of the most outstanding ecosystems for several services they provide. The present study aimed to implement an artificial wetland with treated wastewater to sustain endemic wildlife in a variety of fauna, right, and wildlife, pollinators, birds, reptiles, to aquatic organisms And in this, let us recharge the aquifer, very managed runoff of monsoons to prevent erosion. The site of study is located at the coordinates 31 degrees, as you can see, north, and 110 degrees west in the northwest of Sonora, Mexico, and it extends for 1.5 hectare. To investigate the stability of this site, it was essential to use monitoring methods in order to investigate spatial erosion along with particular dynamics, not only related to water, but also wind and wildlife and gravitational mass movements. This is an aerial photograph of the site. We can see on the right the park of solar cells, which produces electricity to make possible for this wastewater treatment plant that we can see a little bit on the left. And the site goes to this 300 away from the plant, and here appears the winding first channel of the system. Okay, to characterize the treated water with respect to macrobiological quality, and we evaluated Escherichia coli and mesophils as well as biochemical oxygen demand. Also, we had some soil analysis. The method of granule dimension with 10, 20, 40, and 50 mesh was used, and the results evaluated according to the United Classification of Soil criterion. To determine the density of soil as well, we also use a penetrometer test, and we could calculate dry weight and percentage of humidity, and also we determine the infiltration rate as a function of time. The penetrometer is an equipment used to evaluate mechanical properties in soils at 5 feet depth. Unless a significant change in materials is observed, and the method complies with the American standard for testing materials D1586. To investigate topography, hydraulic patterns in the watershed, a Phantom 4 drone was used along with the GPS Spectra Pro Mark 120 post-processed, and they were also evaluated with the Spectra Precision Survey Office and CivilCAD software. To determine the site capacity of this watershed, a computer simulation was performed with Flux of Water software, and also a HE soft photo scan and RMAC to obtain digital models before and after monsoon. Endemic native flora characterization was accomplished with the help of 2 American organizations. We thank Arizona Native Plant Society and Borderlands Restoration Network. The latter contributed with workshops to train collaborators about the germination techniques, especially. A design implementation of the system consisting of 3 channels and an artificial lagoon was built to sustain the wetland. The channels were excavated with a bulldozer and have from 0.30 to 1.5 meters depth. Winding downstream to the pond, these channels just go to a lagoon, which is 0.80 meter depth and with 42 meter diameter, close to a river. There is a wastewater treatment plant about 300 meters away, and from there, water was pumped through 4 inches pipelines, polyethylene to a polyethylene tank before entering the channels. Here we have in the figure 5 what the tanks look like. It's a tank packed with limestone and natural zeolite to pre-treat the water. Forestation, a criterion to select the flora that best could work in the site, was followed with the native grass such as Muhlenbergian regions, Aristida purpurea, Ilaria belangeri, Arunda donax, and Muhlenbergia porter. These endemic plants help define invasive species such as Bermuda grass and buffalo grass, which are not desirable for any restoration project since they are not endemic to the site. Green infrastructure also contributes to the stability of the ecosystem, not only for the inland organisms in habitats to Alisos watershed, but also for aquatic ones. This green infrastructure is helpful also to reduce sediment drag all the way to the river and diminish the likelihood of disappearance of surface effluents. On the other hand, the risk of flooding for nearby communities increases too. This accounts for a favorable social impact. Vegetation layer enhances infiltration and slows down runoff as well. Three principles of these systems in green infrastructure includes a slow sink and spread. For any restoration process, it's compulsory to eliminate the carbon that plant debris may apport. So therefore, to avoid a setback due to the carbon, storage, there was a hard work to take away this plant debris. And this is very important to say that since we teach at university, it was very good to have our students get into the social work in programs to do some of this work. Finally, to monitor the site and determine whether erosion occurs, a number of flights with drone were scheduled. Okay, the table 1 shows the results for microbiological and physicochemical analysis, and it first tells there were issues in the last year with Escherichia coli and Mesophils. That's why we decided on the pre-treatment with the tanks and the zeolite and limestone dry pack. Later on, we also found out that there were no problems with phosphorus nor nitrogen. But biochemical oxygen demand was also to include in this analysis, since biochemical oxygen demand in discharged water can tell very important information about the system. It can tell about the microbiological quality of water. So here we have in the table 2 some of the results with the BOD. And we can see the inlet of the tank and the outlet of the tank. So it seems that the material packed in the conic tanks worked. It's interesting to tell that the permissible limits in international normative set this at 20 to 5 micrograms per liter to discharging natural water reservoirs. Mexican normative, Conagua 2003, establishes BOD as 30 micrograms per liter for treated wastewater discharged into lagoons or rivers, and the pH of 5.5 to 10. Soil analysis. Well, there were some analysis related to the type of soil in the site. As for mechanics, the behavior expected for a soil like this compromises solid foundation and risks brittleness. So it means that we needed to implement some green infrastructure to confront this kind of soil. The average density of soil was 86.83% with respect to maximum dry weight, which accounts for a moderate compact soil. The permeability test outcome was 1.82 liters per hour for infiltration rate. And this includes the ratio of horizontal infiltration to vertical. Therefore, the soil can be classified as semi-permeable with slight retention properties. In order to avoid infiltration, high-density polymer was placed on the bottom of the lagoon of the system. We can see in this figure 7 how we needed to place this geomembrane so that we could hold the water in the lagoon. The analysis that consists in utilizing information derived from topographical surveys through drone and the data processing after with sub-photo scan, which renders images for a definite period of time to study the behavior and dynamic on site. Likewise, it is possible to determine whether erosion or sedimentation could happen from orophoros. From the results, once orophoros were obtained, changes on the site were detected easily with a comparison between the digital models database generated. Once the digital models were obtained, the analysis unveiled the following results. In figure A, we can see that as color changes from green to brown, which indicates the spots where soil level changes occur, erosion or sedimentation can be, investigated. To assess soil erosion and sedimentation, a comparative analysis was carried out, and we can see here in this figure 8. At first, in flight, we had on March 2020, the green areas, and the second, which is in July 2021, it was this year. Now the green appears in color brown. This means that the material was transferred to the green sites, right? Where the material was deposited. And this is the figure 9 with the digital model of change. Other interesting information that we can also find out, was the drainage area of the watershed, calculated as 10.18 square kilometers, where a major flow of 116.49 cubic meters per second on critical event. However, since the neighborhood does not have a net urbanized area, the natural terrain and vegetation contributes to, in this case, a dynamic not very desirable for this kind of projects in the site. Another important factor that reduces the possibility of ponding was the basin, which is up to 4%, and the slope, where the water might run and have some problems and cause some problems. The slope of the watershed is around 2%, and it has been well reported that increased runoff increased sedimentation downstream, what eventually results in loss of material to rivers. Well, this is an upper view of the design system of Alisos watershed. You could see here a 3-channel system in a lagoon. The channels were around 65 meters long winding down to the lagoon, with depth starting at 0.30 meters down to 1.5 meters. Green infrastructure. The hydrologic patterns are closely related to the green infrastructure maintenance, what means that a lot of stewardship added to the environmental education in different levels of work, since one of the principles of green infrastructure requires long-term commitment. So we needed also a regular assignment and also hands-on training. Since we teach this sustainable development subject at the Instituto Tecnológico de Nogales, our students were involved with these activities. Forestation strategies. The plan selected to forest the site were Youngclass Mayor, one of the trees enlisted as a species that is a little menaced in the normative of Mexico. Also Platanus rhyre associated with, in this case, another plant. They are typical of Sonoran wetlands. And also two plants, Asclepias angustifolia and Conoclinium gregi, very valuable to insects like monarch butterfly, especially mentioned with the Asclepias angustifolia because they offer a good shelter and food for the butterflies on their stop during their autumn flight to the central goods of Mexico. A criterion to select the flora that best work to forest was to pick a native grass such as Muhlenbergia regions, Aristida purpurea, Hilarion belangeri, Arundo donax, and Muhlenbergia porter. These endemic plants helped to define invasive species such as Bermuda grass and buffalo grass, which are not desirable for any restoration project since they are not endemic to this region. And they were acclimated mainly due to their good feature for cattle. Another species of great interest due to its longest flowering stage is Conoclinium gregi. This endemic plant starts blooming in the middle of April and ends up to late October, which ensures a supply of food for pollinators in a long period of time, in contrast to other native plants. Conclusions. Well, wastewater from tertiary treatment was used successfully for an implementation of a wetland ecosystem in a semi-arid landscape. The water pre-treated with limestone and natural zeolite sustained endemic flora with respect to water needs, extreme weather conditions in the region related to Sonoran wetlands. The tanks packed with limestone and type clinotillolite type natural zeolite worked out to diminish biochemical oxygen demand in the water. We should remember that biochemical oxygen demand in discharged water is very important to monitor what goes on in the system, since it can tell you about the macrobiological quality of water. Pollinators were a priority to select the plants which were either reproducing in nursery or in some cases replanted. A 4-month period was enough to have Arundo donax growth, 8 centimeters height, while Aristida purpurea took 6 weeks. The aquifer was recharged with a channel and pond design of the system and achieved infiltration in both directions, horizontal and vertical. Despite the type of soil in the site, semi-permeable water was accomplished with the use of rocks and a polyethylene cover. Could I mention this geomembrane helped hold the water in the artificial lagoon. Invasive species were fought back with forestation of native grass. As I mentioned before, environmental education anticipated the hard work involving a long-term commitment for a restoration project. This implies students from local university to get involved, which makes them aware of the importance of recycling water in any community. The use of green infrastructure helped to manage rainwater runoff in the monsoon. This support the study was crucial and favored the use of 1.5 hectare of land with no time required. Any ecosystem restoration program is very complex. Therefore, the authors understand that we have to pursue the system health conditions along with newcomer students from the local university. Special thanks to different organizations. The very one, Organismo Operador Municipal de Agua Potable, this is the system in the water treatment and drainage system of the city of Nogales. Dr. Diana Austin, director of the Faculty of Anthropology in the University of Arizona. Kurt Boff and Francesca Claveri from Borderlands Restoration Networks of Patagonia, Arizona. Lindley Rice and Sue Carnahan of Arizona Native Plant Society. Of course, the Tecnológico Nacional de México, Campus Nogales. The work team, we still work, and it's very important for me to mention, Gabriel Bonillas Garcia, Irma Verónica Gil Delgado, Rafael Segovia Torres, Reinaldo Gutierrez Gutierrez, and of course, our undergraduate student, Barbara Martinez, who recently applied for the exam to get the master's degree. Barbara, thank you very much for your support. Thank you very much.
Thank you for your presentation, Dr. Perfecto. So yeah, do we have any questions? Any questions? Guess there are no questions. Anyways, thanks a lot for your time and your presentation. It was neatly explained.
My pleasure.
Thank you. So let's move on to our next presentation. So we have our next presentation by Dr. Tamás Benyai from University of Minsk, Hungary. So yes. Your screen is visible to us.
Do you see my presentation?
Yes, yes, your screen is visible.
Okay, thank you, dear chairwoman, ladies and gentlemen. I would like to welcome you. My name is Tamás Benyai. I am working at the University of Miskolc, which is a small university in the northeastern part of Hungary in Europe. Within the frame of my presentation, I would like to give you a short overview about the transformation potentials of conventional solid waste collection systems into a cyber-physical system using Industry 4.0 technologies or Internet of Things technologies. The accelerated movement of people towards cities led to the fact that the world's urban population is now growing by about 60 million or 100 million persons per year. The increased number of cities population has a significant impact on the produced volume of household waste, which must be collected and recycled in time. The collection of household waste, especially in cities, in downtown areas, has a wide range of challenges. The collection system must be reliable, flexible, cost efficient, and of course green and sustainable. So within the frame of my presentation, I would like to give you a short overview about the potentials of Industry 4.0. How can we transform conventional solid waste, solid municipal waste collection systems into a green, sustainable waste collection system. In the first part of my presentation, I would like to give you a short overview about the Industry 4.0 technologies, focusing on their potential, which makes it possible to transform conventional systems into cyber-physical systems. In the second part of my presentation, I would like to introduce the physical model of a cyber-physical municipal waste collection system. A mathematical model of this waste collection system is discussed in the third part of my presentation. The optimization problem sorry, is described in the model as NP-hard optimization problem. There are no known efficient analytical methods to find the best solution for this kind of optimization problems. Therefore, I have used a heuristic algorithm to find the suitable solution for the optimization problem in this cyber physical waste collection system. So next, the black hole heuristic algorithm will be discussed, and a scenario analysis validates the model and evaluates its performance to increase cost efficiency and warrants environmental awareness and sustainability of the municipal waste collection system. Production companies have represented a special sector of the economy which harnesses technology to improve availability, efficiency, reliability, and productivity. The ever-changing manufacturing industry requires the improvement of these attributes, and the statistical surveys suggest that by the end of 2021, about 80% of large manufacturing companies will update their operations with Industry 4.0 solutions and technologies, and they will transform their conventional manufacturing environment into cyber physical systems. The integration of IoT solutions leads to hyper-connected value-making chains where not only manufacturing but also the related supply chain, logistics, and service processes are operating in a cyber-physical environment. As this figure shows, Industry 4.0 technologies offers new innovation accelerators like augmented and virtual reality, cloud and fog computing related to the big data problems, additive manufacturing, 3D printing, IoT, autonomous standardized production and material handling resources, smart tools, intelligent products, simulation and digital twin solutions, cyber security, or system integration. These Industry 4.0 technologies are important influencing factors for manufacturing and service processes, and they lead to the appearance of dynamic service networks. Complex manufacturing systems generate unprecedented amount of data that are difficult to handle with traditional computing methods. Cloud, edge, and fog computing make it possible to manage big data problems. Big data is coming from a wide range of sensors from the service system, in our case from the municipal waste collection system. And cloud and fog computing integrate servers, storages, databases to support efficient networking, analytics, and intelligent solutions. The application of digitalization-based technologies enables the virtualization of product and the process planning and control. Digital twins represent an integrated probabilistic simulation of complex products or processes using physical models. sensor updates and cloud-based information to mirror the product or process of its corresponding twin. Digital twin technology makes it possible to convert the conventional physical waste collection system into a cyber physical waste collection system, and this transformation can lead to the improvement of the design process of the logistics of the whole supply chain, adding a real-time phase to the conventional supply process. In conventional systems, the real-time optimization is almost impossible, because real-time optimization is based on real-time data and status information or failure data. Using this digital twin technology and smart sensor networks, real-time data and status information can be collected from the waste management system, and the real-time model for discrete event simulation can be generated to perform scenarios or scenario analysis for real-time decision making. I will jump this slide. The introduction of additive manufacturing will have a great impact on the supply chain processes and logistics solutions, because both external and implant material flow solutions will change dramatically. So it is caused by the fact that this technology is based on the building of 3D objects by adding layer upon layer of various materials like plastic, metal, or organic materials. The next slide shows the one moment, this is intelligent product. Okay, the next slide shows the structure of the IoT technology. The Internet of Things describes an integrated system of computers and mechanical machines provided with unique identifiers. The IoT makes it possible to transfer data through a network among equipment, among resources, material handling machines, tools, products, and ERP systems. The research methodology of this optimization approach is based on two different types of waste collection systems. The first type of waste collection systems is represented by a conventional waste collection, while the second type is a transformation of the conventional waste collection into a cyber physical system, while using Industry 4.0 technologies, smart technologies, in order to increase the performance, flexibility, availability, and cost efficiency of the collection processes. The frequency of waste collection routes are established a priori based on a fixed plan, and they are independent of waste levels in bins in conventional waste production processes. In this case, it is difficult to reach high utilization of collection trucks and other material handling resources, for example, loading or unloading equipments, cranes, for example, while waste collection demands are all performed. Case studies show that in the industrial environment, containers can be equipped with level sensors and wireless communication equipment. The waste collection service provider has access to real-time information on status of each container, and collection routes can be scheduled depending on the waste level of the containers. Another case study highlighted that in the industrial environment, to cope with the uncertainty in deposit volumes and with fluctuations due to daily and seasonal effects, special policies needed that balances the workload over time. The cyber physical waste collection model that is shown in this figure includes customers, technological and logistic service providers. The remote monitoring of field level of bins makes it possible to manage the whole collection process depending on the available volume of waste in the household. The remote monitoring of smart bins can be implemented either as real-time monitoring via Wi-Fi connection or as delayed offline monitoring where the collected data is transmitted through RFID readers. The data collected from the smart bin is uploaded to the cloud storage. The other side of this inverse supply chain can include different waste management methods like dumping, landfilling, composting, recycling, and incineration. However, most of the collected municipal wastes are dumped or landfilled, especially in countries with low income per capita. But within the frame of this model, because of their limited processing capacities, we are focusing on recycling and incineration technologies. The available processing capacities are also available in the cloud through real-time monitoring. The link between households, which are the waste sources, and the waste treatment sites is represented by a garbage truck, which are responsible for the collection of municipal waste and the transportation to the treatment sites. The design and the optimization of waste collection routes is performed by optimization algorithms in the waste collection cloud. The general objective function of the design of this collection process is to increase environmental awareness through the reduction of energy consumption and pollutant emission of trucks, while synchronizing the collection process with available processing capacities. Truck drivers validate all bin emptying processes with handheld. The municipal waste collection model includes households and treatment sites. There are garbage trucks available at the garbage truck depot, which can perform collection services. There are defined storage capacities at the treatment sites where the arrived waste can be stored until the processing. The decision variables of this model are the following: assignment of households to routes of garbage trucks, and scheduling of garbage trucks depending on the field level of bins and available processing capacity of the treatment sites. The integration of this assignment and scheduling problem represents an MP-hard optimization problem. The objective function of the problem describes the minimization of the energy use of the collection process, which includes five important parts. The first part is the energy usage of garbage trucks from garbage truck depot to the first household, where waste must be collected. So this is the initial age of the collection route. The second part is the energy usage of the garbage truck among the households. These are the internal ages among vertices representing the households. The third part is the energy usage of the garbage truck from the last household of the collection route to the treatment site. The fourth part is the energy usage of the garbage truck from the treatment site to the garbage truck depot. This is the closing age of the collection route. And the last part represents the energy usage of the garbage truck from the treatment site to the next household. This is the initial age of the succeeding collection route. Energy usage refers to the diesel fuel consumption of trucks, depending on the length of transportation routes and the loading of the garbage trucks. The first part of the energy usage function includes the sum of energy usage of the garbage truck between the garbage truck depot and the first scheduled household. And the energy usage is a function of the specific energy consumption of the garbage truck without the loading and the length of route between the garbage truck depot and the first scheduled household. The second part of the energy consumption function includes the energy usage of garbage truck among households, excluding the route from the garbage truck depot to the households and the routes from households to treatment sites. The third part includes the energy use of garbage trucks from the last household of the collection route to the treatment site. The fourth part is related to the sum of energy consumption of the garbage truck between the treatment sites and the garbage truck depots. And the last part shows the sum of energy usage of the garbage truck between the treatment site and the first assigned household of succeeding collection routes. The solution of the above described integrated scheduling and assignment problem are limited by constraints that are related to time window and capacity. Time window related constraints are defined in the case of households and treatment sites, while capacity constraints can be defined both for garbage trucks and treatment sites. We can take different types of constraint consideration. For example, constraint 1 defines that the capacity of treatment sites is limited, so it exceeds its treatment or processing capacity. The second constraint says that we can define a capacity limit for garbage trucks, and it is not allowed to exceed the upper limit of the loading capacity. The third constraint says that we can define a time frame for the delivery time to the treatment sites, and it is not allowed to exceed the upper and lower limit of this time frame for the delivery. And the last constraint says that we can define a time frame for the scheduled emptying of bins and the customers, and it is not allowed to exceed this upper and lower limit because in this case the service level will be decreased. The next part of my presentation will focus on the optimization algorithm of this scheduling and routing problem. The optimization algorithm is based of a so-called black hole heuristic, which is a meta-heuristic optimization method. Black holes are strange and fascinating places in the space where the gravitation forces are so high that they can trap not only particles, planets, and stars, but also the light. The black hole optimization is based on this phenomenon of black holes. Black holes have 4 layers in our optimization process: space outside the photosphere, space between the photosphere and the event horizon, space inside the event horizon, and the singularity where the mass of the black hole is concentrated in one single point. The photosphere is a spherical region of non-spinning black holes. Photons reaching the photosphere are not captured, but they are forced to travel in orbits. The distance between particles and the black hole has a great impact on the behavior of the particles. If the distance between a particle is much higher of the event horizon, then the particle can move in any directions. If the distance is larger than the Schwarzschild radius, but this difference is not too much, the space-time is deformed and more particles are moving towards the center of the black hole than in other directions. The first phase of the black hole heuristics to find the optimal solution for this cyber-physical waste collection system is the Big Bang phase. This phase is the initialization of the position and velocity of stars in the multidimensional search space. The stars represent potential solutions of the optimization problem, where the coordinates of the stars in the search space are the values of the decision variables of the physical optimization problem. Stars can be initiated only inside the search space. The second phase is the evaluation phase. In this phase, we can calculate the value of the objective function based on the parameters represented by the coordinates of the star. The third phase is the selection of black hole. Within the frame of this phase, a new black hole is defined as having the highest value of objective function. This star has the highest weight, represented by the value of the objective function, and therefore it has the highest force of gravity, and it is the center of movement of stars in the next movement phase. Moving of the stars is the next phase. In this phase of the algorithm, a new position of the stars is calculated. The movement of the stars can be influenced only by the black hole, but it is also possible that we take the gravity force of other stars into consideration, but in this case we are talking about gravity force heuristics, which is another type of swarming heuristics. The next phase is a special part of the black hole heuristics. In this phase, the size of the event horizon and the photon sphere is decreased based on the Hawking radiation phenomenon, which describes the lost weight process of black holes. This phase makes it possible to prevent the absorption of stars, representing solutions of the optimization problem near the optimum. And the last phase of the optimization is shifting the position of the black hole. In this phase, we use the idea of Hawking radiation. Particles can escape, and the black hole's mass reduces, because if a particle-antiparticle pair is created beyond the event horizon, it is possible. It is not a must be, but it is possible to have one drawn into the black hole itself while the other is ejected or rejected. The position of the black hole is shifted using the calculation as you see in the slide. On the basis of the above mentioned aspects of the black hole heuristics, it is possible to perform the optimization with different variations of the standard algorithm. And as the table shows, the decreased Schwarzschild radius, the Hawking radiation, and the lucky star options increase the performance of the standard black hole algorithm. Therefore, we have chosen this type of black hole heuristics to solve the optimization problem. So within the frame of the last part of my presentation, two scenarios will demonstrate the application possibilities of the described mathematical model and validate the applied heuristic optimization algorithm with different data sets. The optimization algorithm takes care of a fleet with different trucks, and we can also choose different bin sizes. But the scenarios which were shown here are simplified to make the examples as visual as possible. The table demonstrates the generated waste volume in each household for a time period of 10 days. We use these volumes to analyze the different strategies of waste management system in the case of a conventional operation and in the case of a cyber physical system. The processing capacity of the treatment site is, in this case, 450 volume unit per day. The loading capacity of the garbage truck is about 1,000. In this case, we only use the above described heuristic optimization for the routing of garbage trucks, because the scheduling is a static sequence scheduling, and there is no available information on bins loading level. In the case of this first scenario, the waste management system is performed as a traditional or conventional collection system without the use of IoT technologies. The coordinator of the waste management system has no real-time information regarding the waste level in the household bins. Therefore, the emptying process of bins is scheduled as a sequence of periodic collection routes. The table shows the calculated generated waste in a household in the case of periodical collection routes every 2 days. The number in the red boxes show that the households and time windows exceeded the loading capacity of bins. It means that the garbage trucks collected the waste later, and the waste bins were full in the following cases. In the fourth time window, 3 customers. In the 8th time window, 1 customer, and in the 16th time window, 4 customers were not sold out in time. So the availability of the waste collection service level was about 80–85%, and the customers stored about 100 volume unit waste outside the bin within the frame of the time span of the analysis, and it is not allowed. The left figure shows the waste volume that was transported to the waste treatment site because of the lack of information of bins loading level and the static periodic scheduling or collection routes. The transported volume and the available processing capacity are not synchronized. As the right figure demonstrates, storage capacity must be available for the storage of waste to not be processed. The routing algorithm calculated sequence as an optimal collection route, and we can calculate the length of the collection routes, the diesel consumption, and related to the diesel consumption, we can calculate the greenhouse gas emissions. After rescheduling the collection routes within the frame of the time span of analysis, the length of the total collection route was increased with an additional diesel consumption. This additional diesel consumption, which was caused by the additional relations, increases the GHG emissions. And as the summary of this scenario, of this first scenario shows, the calculated emission of collection routes demonstrates the environmental impact. In the next slide, in this case of the second scenario, the waste management system is performed as a cyber physical system where Industry 4.0 technologies and paradigms support the optimal operation of the processes. In this case, we can optimize the collection routes, and we can calculate the emission rates. As the left figure shows, the waste volume that was transported to the waste treatment site is lower. Within the frame of this scenario, the collection process is optimized from an environmental awareness point of view, including the minimization of emission of garbage trucks, and the transported volume and the available processing capacity is not synchronized. The right figure demonstrates the storage capacity must be available for the storage of waste that is caused by asynchronous supply. The above discussed the scenarios validated the present cyber physical model of waste management system in the collection of municipal waste, and justify the fact that the application of Industry 4.0 technologies to transform a traditional waste management system to a cyber physical system strongly influences the performance of the whole supply process, while sustainability and the environmental awareness are also taken into consideration in the form of minimization of energy consumption and emission. To summarize, as a last sentence, I would like to say that the proposed optimization model that was based on the black hole heuristics makes the analysis of the impact of scheduling and assignment on economical and ecological aspects, where public health is influenced by the emissions that are caused by the collection process possible. So I think that my time is over, so thank you for your kind attention.
Thank you for your presentation, Dr. Thomas. So, yeah, do we have any questions? Any questions or any comments? Okay, I guess there are no questions or comments. Thanks a lot for your time on your presentation. So for the next keynote presentation, we have yeah. So yeah, for the next keynote presentation, we have Dr. Stephen Salter from University of Edinburgh, United Kingdom. So
Hi.
let me make you the presenter.
Advice about
Yes.
how to share my screen with you.
Yeah, please do.
Right, I've been made the presenter. I click on the screen that I want you to see. Share.
Mm-hmm.
Does that look as if it's promising? Yeah.
Oh, your screen is not yet visible. Yeah, now it's visible. Yes.
Okay, brilliant. Right. Very early this morning, I did a talk about a way to make clouds whiter, and it all started off with a picture like this, which is a satellite image. This is the Bay of Biscay, and this is the English Channel, and there are these strange white streaks going across it. Not the movement of ships going across, and it's the exhaust in the ship wake that is making the clouds a bit whiter than they would have been otherwise. You don't always get this. In fact, it's quite an unusual feature, and it may be something to do with there being especially low turbulence on that particular day. This was studied by this chap here, Sean Toomey, and he could fly into clouds and measure the size of the drops and the concentration of the drops and the energy coming down and the energy reflected up. And he showed that the reflectivity of clouds depends on the size distribution of the drops. And if you have a lot of small drops, you get a white cloud, and the same water in a small number of bigger ones gives you a dark one. You may have heard people say the dark storm clouds are gathering. And this is now well accepted, and you can prove it with different sizes of glass balls. They're 4 millimeter here, 40 micron here. And we can use this to make the clouds reflect a little bit more solar energy back out to space. At the moment, our problem is about 1.7 watts per square meter of solar energy being retained that we would rather not have. And the solar input is 340 watts per square meter, 200 times more. So 0.5% increase in the reflectivity of clouds could solve the problem, or at least the thermal part of the problem. And we can use the Sean Toomey result to do this. And the reason why it's really very important now is shown in this diagram, which is about the stability of an oscillating system, which might be wiggling around like this, or it might be wiggling around like this, or it might be flipping over from this area into this area where you get a completely different set of conditions. And one of the things that would indicate that you're near a transition like this is a lengthening of the period of a particular weather condition. And if you change quickly, then you're probably nice and stable and stiff. And if something is lasting for a long time, that's a warning that you might be getting to a flat bit, which could go wrong. All right, this chap here, John Latham, realized that we could use 2 to cool the Earth, and he did all the calculations, and he found that there's a logarithmic result like this. If this is the amount of cooling you want to do, this was done when it was 1.6, it's 1.7 now, you'd need to spray about 10 cubic meters of water a second for the whole world of the right size of drop. That sounds quite exciting, doesn't it? And this was tested by some people at the Hadley Centre, who are a top laboratory in the UK for climate stuff. And they showed that, this was 2009, they showed that spraying in 3 different regions, which they thought were very good, the Northern Pacific and the South Pacific and the South Atlantic, could give you a cooling of 0.97 watts per square meter, compared with 1.7 now. So that's a big fraction of the problem, but it's only using 3.3% of the area of the world. Okay, I've got something out here which I don't want. I'll expand that. Okay, so a tiny bit of the world's oceans is doing a major job in the cooling. And what they did was to pick 3 places: the North Pacific here, that's California, that's Peru and Chile, and this is off Namibia. And the North Pacific one gave you a little bit more precipitation in Australia, and the South Pacific one gave you a little bit more here as well. But the Namibian one reduced precipitation in the Amazon here. Okay, now it actually didn't reduce it that much. It dropped it by about 1 millimeter per day, and they get 2,000 millimeters a year. So it's a tiny, really quite a small fraction. But when it was drawn like that, it really looked horrible. It looks like a sort of cancer growth or something. If you did them all together, that wasn't quite as bad because these other 2 were helping a bit. But nevertheless, that was a nasty looking thing. And the Met Office published it like this without saying what regions were causing the problem, which regions they were spraying and how much you were spraying. They just, journalists assumed that this was what would happen wherever and whenever you did the spraying to make the clouds whiter. And this actually would probably not be detectable by people living in the Amazon because it's quite a small fraction of what they get altogether. In contrast to that is some results from Norway, where instead of picking just these tiny little 3 places, they just sprayed anywhere where there was low cloud over the sea. And this gave a very nice cooling in the Arctic, where we're worried about methane releasing. And it also gave useful extra precipitation in the Sahara and South Africa and Australia and Mexico and all over. The only places where it's reducing precipitation are all over the sea, where we may have a problem if there's islands who are not getting as much rainfall as they wanted. So we have a situation where can we design a better way than just looking to see where there are clouds? And that's what I want to talk about. And we've got a very noisy system, and there is a technique in electronics called phase sensitive detection. And this is used to get information about a tiny low strength signal that's buried in a lot of noise. And if you know the frequency of the signal and its phase, you can detect a tiny signal in the presence of a very much louder noise. So if you've got a satellite that's trying to send you signals from Pluto or somewhere, you can use phase sensitive detection, and the signal to noise ratio improves with the square root of the time of the observation. So you may be slow, but you will get there in the end. And we need to find a way to get this system going for the climate system. We need to be able to measure the effects of putting spray in different places on lots and lots of other places. All right, the next thing I've got here is a temperature record over 8,000 days. That's quite a long time, from Camborne. It was given to me by the Hadley Centre. It's very nice. And you can see these are, one cycle is of this noisy thing is a year, right? So you've got all that number of years, like 20 years, I think. And what I wanted to do is to try and get rid of the main sinusoidal bit, which is shown by this blue thing. And I just tweak this equation here to get the fundamental and its second harmonic. And that allows me to clean this up to get rid of the annual variation and just look at the random day-to-day stuff. And I ended up with this signal. That's just the first 2,000 days of it, and you can see that we've suppressed the main annual stuff. All right, and then what I want to do is to change, deliberately manipulate this Camborne temperature in different amounts, increasing it in some patterns and reducing it in other patterns and jiggling about on it. And then I want to try and find out what the amplitudes of the different jiggles were, knowing only the sequence of the ups and downs. And if I go to here, you can see this is a pattern of pseudo-random sequences. If you imagine that you're increasing here and reducing here and increasing here and reducing here, and these are 16 different ones. And when God made pseudo-random sequences, he made a lot of them, so you can have lots of them. And provided you know what each one was, you can detect its fingerprint in a noisy situation. And this is what it might look like if we're changing. The blue is the red signal minus the stimulus when the stimulus is on, and it's the red signal plus the stimulus when it's off. That was just a way of showing it. But if you do that with not just one, but with 16 different ones, you are getting an even noisier signal. And then what you want to do is to see how big the different amplitudes were, knowing only what the sequences were. All right, and I did it with all these different sizes of temperature change, 1.2 C and 1 and 0.8. This lot here are warming, and this lot here are cooling. And I've done this, I think, 9 times here, and you can see how accurately we can get the information that it was a 1.2 change here or a 0.8 change here. And this is really quite good. You need quite a good thermometer to measure that. And this was then tried by a part of a PhD, by a rather bright PhD student at Leeds University called Ben Parks. And what he did was to break the sea up, the ocean regions up, into lots of different regions, all right, and then jiggle the number of nuclei in the climate model that for this particular region, either putting it up or down in random sequences for each region, all right. And he wanted to know is what each region, each of these 89 regions does to every bit of the land, and how each bit of land is affected by each sea spray station. And he came out with this result where we're finding out what all the different oceans do to this black bit. And red means it's making it wetter here, and blue means it's making it dry here, all right? And lo enough, we get this Namibian bit making this bit a little bit drier, but lots of other places where it's making it wetter, particularly up here off the Aleutian Islands. Why the hell does that spraying here make it wetter here? That's several PhDs buried in that. And he found also that this bit off Namibia is making this bit drier, but all these other ones are making it wetter. And the next thing he found out was there's a whole bunch of 89 different ones, sets of ones here, which are producing changes in the precipitation for somewhere in the Middle East. And if there's no change, this line here, the 0 line, that says that wherever you do it, it doesn't affect this particular place. But these regions here are making it a bit wetter, and these are making it a bit drier. So we can find out where we mustn't do this or where we should do it. And there's a whole bunch of results for other places where you can see all these different black places are affecting increases or reductions in all the different parts of the world. Now, I wrote this up for a rather prestigious journal. It was the editor of the journal asked me to write this up for the journal, and I did this, and a referee rejected it, so I haven't been able to get this published yet. And what's amazing is that all the climate models that I've sent this to have not shown any interest, but they haven't even asked me for this data, for this results, which is a big puzzle. And I'm doing this presentation in the hope that somebody who's doing climate modeling will come along and do the next phase of this, which would involve avoiding the very sharp square things. We want to make these lots softer. And we also want to find ways of combining them in sort of choirs where they're getting in harmony, where we can combine all the ones that made it rain in one place, so that they all get together and their effects are combined. And this would then allow climate planners to look and see what was happening, what the trends were, whether we're going to be getting a drought in so-and-so, and to adjust the places in the sea areas where we would be sending the ships that are going to be making the spray. There are probably quite a lot of you who didn't hear the first presentation today, but I understand it's being recorded, and I think you'd probably make more sense of this if you were able to look at that recording. I hope there are some climate modelers attending here, and if you'd like to send me an email, please do so. It's S for Stephen .salter like pepper, s.salter at ed.ac.uk. Can I try and answer any questions? Probably you're all too shy.
Do we have any questions?
While you're thinking about the questions, I'll show you a few ships. I think that one should do it. Well, that at least gives you my email. Let's look at some of the ships that would be. I'll flip through here. This is about the engineering, and what we want is to have that sort of ship here, where the ship is being driven by spinning rotors called Fleckner rotors by the wind. All the energy is coming from the wind. The hydrofoils that it's flying on, it's not floating, it's flying, have got variable pitch, so that if the angle of incidence on this one here increases and that one reduces, this one will want to go up and that one will want to go down, and you can do the opposite phasing at the stern, so that you can drive hydraulic rams to make the energy to make the spray. The spray comes out horizontally, it cools the air so it falls down. It doesn't get into the sea, it sort of skims around the top of it until it's got some heat back, and then it can be moved by the turbulence up into the cloud region and give the more condensation nuclei and therefore smaller drops and whiter clouds. And that's the engineering, which you won't be able to see the detail of. All right, okay, that's my time up. Any more questions? No.
Any questions? I'm sorry. Okay, I guess there are no questions. So thanks a lot, Dr. Stephen, for your presentation. It was informative and interesting.
You're very welcome.
So let's move on to our last keynote presentation, and that will be by Dr. Hosam Bayoumi Hamouda from Obuda University.
Yes, I'm here.
Yeah,
Did you hear me?
yeah, we can hear you.
Okay, just I will put my lecture.
Yeah, I have made you the presenter. Kindly click on the screen button to share your screen. Yeah, your screen is visible.
Just make, because I have.
Yeah, your presentation is also visible.
Okay, just a moment, because I have to remove this. Just a moment, please, because I have to put it on a big scale. Just a moment. No, it doesn't matter. I hope that it will be clear to you if we can put like that. Yes.
Yes.
Okay. More, and I have to put it on this one. Just a moment. I hope that's clear now.
Yes, that's perfect now.
Yeah, okay. I don't know. Now we have at Budapest time, we are in 16:40. I have to say, not good afternoon, but we are going to be good evening. I am Hussam Bayoumi, doctor, a professor in the University of Abu Dhabi, and I am also the president of the International Council of Environmental Education, Environmental Engineering Education. My main specialization is soil environmental microbiologist and soil biotechnologist. Yesterday, I'm talking about the environmental sustainability and how can we consider this point of view for our future. And today I have to say something about the soil protection, because if we have a good soil, it means we have good food, it means we have good health. And in this case, we have to be very careful when we apply anything about the for the soil. Today, one of the most pressing environmental and environmental problems is increasing volume of waste, including wastewater, amendment, sewage sludge application, utilization, and disposable. This is the main point of the organic matters which can be involved or added to the soil. Monitoring of soil properties is the most important concepts of the environmental biotechnology. So in environmental biotechnology, microbiological and biochemical parameters are one of the most essential characterization to qualify the soil health when amended with sewage sludge. Not only sewage sludge, but our team is sewage sludge today, but to any other additive material to the soil. The biological activities of the soil are determined by several microbiological and soil enzyme activities together. Demographic growth of the demographic growth and Western economic model seriously maintains this vital sources, soil security, scarcity, soil losses through erosion, natural disasters, and contamination, water scatter, and contamination, as well as limitation and extraction of the mineral resources and fossil energies. The key words that I would like to say about it today, my lecture will be concentrated about the monitoring, the rhizosphere properties, microbiological, biochemical, ray plant growth, as well as the sewage flush. How these keywords are combined together to form one of the main topics in my projects. The objective of this model of experiment were to determine the effect of sewage sludge application on what? On biological, which contain different microbial and activities
of enzymes properties, carbon dioxide production, and physiochemicals like pH, soil moisture properties, ray, plant growth, and the productivity. We grow up these plants for 9 weeks in a greenhouse. We use in this investigation two types of the soils. Almost they are Hungarian soils. One from the Nyíregyháza, it's the city we found in the eastern north part of the Hungary, as well as we have in the south of Hungary this Chernozem soil. And we also mixed these two soils with different concentrations or different doses of sewage sludge. Generally, we give the 20, 40, 60, and 100% soil or sludge amendment to the original soil materials. The source of this sewage sludge is coming from the Nyíregyháza sewage water purification, and this was a very preliminary investigation. Results of this experiment show that the soil retained in the moisture content for a longer period than the free wastewater sludge control soil. As we'll see in the graphs, also we can show that the soil pH was maintained to be favorable for plant growth more than the control. So here there is something coming from the amended material, is a sewage sludge. And in the first graph, we see that the effect of sewage sludge application on the soil pH in the two soils we have in Nyíregyháza and Chernozem soil, and found there is no significant difference between the application of sewage sludges into this soil amendment, comparing to the control, or even comparing with the 100% sludge. If we can grow the plants in a pure sludge, we can find the pH of the sludge remain without any differences. But in the application of the sewage sludge on the moisture content in the two soils, we found this significance coming from the two soils. It means there is a benefits of use this kind of sewage sludge, which contain a higher amount of organic matter, which keep the water content or the moisture content of the soil for a longer time. On the effect of the plant growth, we determine the dry weight. I would like to only the dry weight here. The application of this amendment on the soils doesn't give any significance, but the application dose will give significant growth if we compare with the control. Here we can see the control without only in a pure soil, and in 20%, 40%, 60%, and pure sewage sludge, we found that 40 and 60% give maximum dry weight of the ray plants. Regarding to the activity or biological activity using the fluorescein diacetate enzymes, we found that there is differences between the soils at 40 and 60%, even in the 100% of the sludge treatment. Also, we can find the emission of carbon dioxide. We found that by increasing the dose of the mixing the two soils with the same amount of sewage sludge, we found that the emission is increased by increasing the dose of the sewage sludge application. Finally, if we can find that the maximum carbon dioxide emission was happened in a pure sewage sludge, and in this case, the biological activity in this cultivar or cultivated material will be high, full with microorganisms Regarding to the application of this sewage sludge to different kinds of microorganisms, we found that control 20, 40, 60, and 100%, there is a significant difference between the full number of aerobic heterotroph non-spore forming bacteria. And here we have the endospore bacteria group, and we have here the actinomycetes, actinobacteria. Here we have the phosphate fermentous fungi. We have here the content of yeasts, and we have about information about the cellulose decomposing microorganisms. And also at the end, we measure the difference between the phosphate dissolving or solubility microorganisms as well. Here we can find there is no significant difference at all between the all treatments. Here we can find only at the low treatment we can show there is something happening. Similar case, we can also compare our results regarding to the second soil types from second is Chernozem soil types, and also the same tendency coming from this both experiment. Regarding to the special kinds of microbial content, we found that here we can find the presence of the amount of the Pseudomonas number in the rhizosphere of the ray plant, and also we can find here is a community of the Bacillus group present in the same rhizosphere, comparing with other kinds of microbes. Here we have the application of sewage sludge on the enzymatic activity. We have here different kinds of enzymatic activity. We use here, for example, the beta glycosidase. We have also aryl phosphatase and dehydrogenase and etc. And we found there is a significant difference between some of the treatments according to the activity of these enzymes in Sagat soil, it means in the Chernozem soil. But in the Sagat soil also we have measured the phosphatase. We have used the circulase enzymes, and we found that there is some significant difference coming during the increasing amount of application of sewage sludge to Chernozem soil. In case of Nirchihaza, we have the similar tendency that in 40, 60, and 100% where the plant grow, we can find in the rhizosphere of this plant that this sort of enzymes, for example, cellulase enzymes, is more than in the these doses compared with the low or free control soil. According to the similar activity in Nirchihaza, these enzymes show different application and different activities regarding to the amount of the sewage sludge added to the soil. And here we can find that comparing on the first one with beta glycosidase, we found that it's more increased, but in 100% sludge, the activity of the enzyme is reduced. Where in other cases, there is some enzymes or some enzymatic activity are increased even at very high dose or in a pure sewage sludge material. Similarly, we can find that the urease and catalase, urease, and protease enzymes in the Nirchihaza soil. We found that there is a similar trend that the activity of the enzymes is increased by increasing the dose of organic matter applied or sewage sludge applied. In addition to accepting healthy growth and development, the plants also produced the greatest dry matter mass on the soils with the largest portions of sewage sludge between 60 and 100% in a pure sewage sludge soil, as we show in last figures. Also, enzymes or enzymatic activity in the soil samples treated with the sewage sludge were increased in soil with high sludge doses. There was an increase in the density of microbial population in the rhizosphere as sludge dose increased. Here also we can find that the ratio between gram positive and gram negative is completely different, but we say that the gram negative bacteria were dominant in the ray plant rhizosphere, and the ratio between gram negative gram positive bacteria in the Nirchhazi soil and Chernosium soil were 2.367 and 2.35 respectively. It means if we can see this ratio, it more or less they are similar not similar, but they are near to each other. I don't like to speak too much about it, but mainly I'm waiting for the questions and for your opinion about using this sort of organic matter which is produced in a huge amount, and we don't know how can we use it. I will tell you a story later on, but in the conclusion, we can find that soil treatment with sewage sludge stimulates plant growth and also stimulates the biochemical and microbial properties in the rhizosphere of the plant. It means there is something which is stimulate this biological activity. Generally, you can say microbial or enzymatic process of these are biological characterizations. Regarding to the organic matter and nutrient content in the sludge, we found that it is important that it should contain good value of the nutrient material, macro and micro. And regarding to the macro or essential elements or heavy metals, we have to be very careful. I will tell you the story later on. For maintaining this quality, we would like to recommend to treat acidic soil with the ratio 60% of this sludge to improve the fertility of the soil. So if we have acidic soil, and we can find that this kind of sewage sludge, it is little bit not alkaline, but a little bit neutrally. It means we can increase the pH of the soil, which gives the ability of the plant to grow up. Our result also shows that the microbial activity of the soil depends on the carbon and nitrogen contained. In other experiments, we found that the microbial biomass, carbon and nitrogen, phosphorus and sulfur, they are reach a good value when we applied this sort of sewage sludge. That's not shown here because it is a very huge amount of results. Can't really to explain in 1 minute. Soil enzymatic activity increased with the addition of the sewage sludge. Due to the periodic treatment of the soil with sewage sludge, we have to consider this point. It means we are not going to add at every time this sort of organic matter. because of the accumulation of the heavy metal in the soil, and in this case, it will give a irreverse reaction against the biological characterization of the soil. Accordingly, we have to say that this soil sludge may contain heavy metals and levels that reduce soil fertility and activity of the soil microorganisms. If we are always going to add or treatment the soil with certain materials, it means, as I told you, accumulation of heavy metals, we have to be very careful. In some experiments, we measure the bioavailability and bioaccumulation of the heavy metals of the soil with different plants, but we found that it is very bad if we can always adding this sort of materials to the soil annually, or as we suggest in other experiments, or according to the other experiments, the result of the experiments, that we have to say that every 3 years we have to check up or monitoring the heavy metal content of the soil, and we have to study the bioaccumulation of the heavy metals in microbial content and their effect on the soil activities. A balanced state can be achieved in the vital nutrient cycle of the plant. The challenge of the experiment model is to define the best and first quality parameters according to the agricultural use of the sewage sludge of the European level, keeping one eye on the need of the European agriculture as a whole. So we don't like to destroy our agricultural system, our soil quality, but we are going to replace some organic matter instead as a fertilizer, as an organo fertilizer instead of the chemical fertilizers. And we have the problem with chemical fertilizers that every 10 years the pH of the soil is going to be acidic, more acidic than others. Sewage sludge has improved the soil fertility. Of course, we investigate the amount of carbon, nitrogen, phosphorus, sulfur, and macro elements like calcium, magnesium. Also, we measure the content of sodium and potassium, as well as we didn't find any isotopes within the soil. And in this case, we can say that this sort of native or amendment improve the physicochemical properties of the soil. At the same time, due to the effects of the food safety, the use of continuous state monitoring method is recommended, as I told you from a few minutes ago. And this is my story in short way, and thank you for your attention.
Thanks a lot for your presentation, Dr. Hossam. So, do we have any questions?
Yes, I have a question. Many questions.
Yes, Dr. Yeah, please go on.
Okay. Thank you, Dr. Hussain, for your everything. There's some noise, please. There's some interference.
Actually, I didn't hear you, please. A little bit loudly.
No. I heard other voice. So please, if you can mute your mics, please, so I can talk. I heard some noise. So thank you very much, Dr. Hussain.
Thank you. I would like to say that in another experiment, we use some sewage sludge which contain high amount of heavy metals, and make the comparison between low and high, and we found the using of heavy metal of sewage sludge with high amount of heavy metals, it is dangerous to our agricultural system completely. Plant production and microbial content, as well as the enzymatic activity in the soil. Yes, please.
Okay, thank you very much. So I'm really interested in your work because I've been myself working on soil sludge reuse for more than 20 years and under different environments, like from semi-arid environments to cold to United States, Japan, Tunisia, and now Qatar. So I'm really, I mean, I have many questions to. Okay, just you can Google my name and in Scholar you can find my publication. So I have.
Yes, I have a very easy email. That's my name is Bayumi.
I know. Not, okay, of course. I saw your name. No problem. So my question.
Okay. The email is only the email. The email that you can send to me an email, and I will be answering you as soon as possible. Bayumi.Hussan.
I know. Okay, I saw your email, doctor. No problem. I have your email in the list. So my question is.
Welcome to any question. I am happy to cooperate with anyone.
Okay, I'm very surprised to see that you use such high amounts of sludge. I mean, until up to 100%. I mean,
it's not that. It is only as a control. We have a pure soil and the pure sludge, and I would like to see what is the reaction of these two controls with the growth of raw plant. Only for comparison. But the treatment, as I said to you, that it will be between according to this experiment. Because in other say that it is very high, and we reduce the amount of the application to be between 30 and 40.
Okay, you know, even for 30 and 40%, and 60% is still high.
Yes,
please, doctor,
I say,
can you let me, doctor, please? Can you let me finish first and then you answer?
Excuse me,
doctor, please. Can I finish my question? Then you can answer me, please.
Yes, okay.
Just give me 2 minutes.
Okay.
So, okay, thank you. So even 40% corresponds almost to 400 tons per hectare, which is extreme. So my concern is that in your presentation you didn't give any results about heavy metal accumulation. You know, there are many other pollutants actually, like antibiotic resistant bacteria and organic pollutants and emerging pollutants. So salinity also is, I mean, a big concern of soil sludge use. So my question is, where are these first these parameters? Second, what are the parameters of soil structure? Because sometimes sludge will destroy your soil in terms of, especially of clay flocculation, especially you work in heavy soil, cernosium, like in Hungary. And third, why are you using sludge in Hungary? I mean, first is acidic soil. Even if you add 1,000 tons per hectare, it will never change the pH that much because soil has a strong buffer capacity. So you risk with acidic soils that your heavy metals, even at small amounts, they will be bioavailable. So I don't know, for example, sewage sludge could be used in semi-arid regions where soils are depleted. But in Hungary, where soil is more or less rich, I mean, I know that people, they more use like cow manure. So why sludge in such rich soil country? Thank you.
Okay, can I answer?
Yeah, the floor is yours.
First of all, I work with this project since 1997 until 2009, and after that I stopped working with these topics. Why? Because I found that this sort of experiments and application of using plant in such a soils, it going under the topics of phytoremediation. And phytoremediation, from theoretical point of view, it's excellent, but from practical point of view, I can't accept. Why? Because as you mentioned that, as I mentioned also too, we treat the plants or treat the soil with sewage sludge of high heavy metal content. And the plant, of course, when it grow up after 9 weeks, we have to measure all minerals in dry matter, as well as the physiochemical properties of the soil after and before the treatment. So we found that when the soil treated with a high content with heavy metals, there's a miserable situation that the plants, what I work with the plants, they are mostly tolerant and accumulate and hyper accumulate of heavy metals. And I have in my laboratory a huge number of paper packets which contain the materials, and I don't know how can I lose or how can I give this materials, because I can't burn it, I can't throw it away, I can't put it in the water, I can't dump it in the soil, because everything will turn back to the soil. This number one. Number two, the uses of sewage sludge. I have, or we have here in Hungary, a zone between. We know that we have in Hungary here two main rivers, the Danube, Blue Danube, and we have Tisza River. In between these two rivers, there is a very salty environment, and this salty environment can be treated with sewage sludge to evaluate or to increase the pH, and when we grow the plant with different kinds which can tolerate a little bit salinity, because if we can use 5.7 pH, we can reach up the or decrease the salinity or decrease the pH of the soil from 8.5, for example, to be around 7 or lower than 7, between 7 and 6.5. In this case, we can got plant growth. But also we have a point with sodium and potassium, calcium, magnesium, nitrate, chlor, and sulfate, as well as in some places phosphate is there. And we try to cultivate some plants which can, which are able to absorb this sort of material without any damage. And we can do it for another purpose, usually for other purposes. But the main topics, if we can grow or improve the soil quality in these zones, it will be a great task. The second part of the question, why we use sewage sludge in Hungary? Exactly because first of all, the shortage of the water. We are facing now, or in the future also, we will have to be very careful about water security as well as food security. Mean we don't like if we don't like to apply any chemical polluted material, even ammonium nitrate. We can say it's ammonium nitrate is a polluted material because first of all, under microbiological processes, we can go through nitrification and denitrification, and we lose about 30% or 50% of the nitrogen from this sort of nitrate fertilizer to be returned back to the soil, and the other 50% will be used by a plant and microbes in the soil. But according to the biology of certain microbial component in the soil, we don't know what will go. It will go for denitrification or going for ammonification, or we're going to where, or we can go in a slow step to be all of them denitrified. So keeping in the fertility as a humus, because we apply this sewage sludge as a high content of organic matter, and this organic matter will be slowly decomposed by microorganisms, not only first of all in a week, but loosely and safety and extension of the breaking down of this sort of organic matter will take time. So we are not going to give all materials for one crop, but it can grow for 1 year, for 2 years. That's why we monitoring to manage or monitoring the physiochemical properties of the soil every season. It means after.
Thank you very much, Doctor. Thank you. It's clear. Thank you.
Okay.
Thank you very much.
No problem. Yes.
Do we have any other questions?
And by this way,
I
we
guess there are
are
no more
protecting our soil against environmental pollution. Any more questions?
Any more questions? I guess there are no more questions. Anyways, thanks a lot for your presentation, Dr. Hussam.
Thank you very much. I have one
time.
request.
Yes,
I have
please.
one request. That can you send to me a certificate that attend the conferences?
Yes, you will definitely receive the certificate after the commencement of the webinar.
Okay. Okay. Thank you very much.
Yeah. Thank you. So now let's move on to our next presentation, that is by Dr. Nabila El Alami from Maulay Ismail University, Morocco. So yeah, let me make you the presenter. Yes, your screen is visible to us.
Can you hear me now?
Yes, we can hear you now.
I'm very glad that this is your resolve. Thank you very, very, very much. I'm sorry for the problems.
That's completely all right. Yeah.
Hello, everybody. Let me introduce myself. I'm Nabila Al-Alami, a teacher researcher at Moulay Ismail University of Tunis, Morocco. Before I begin, I would like to express my joy to be with you today and to participate in this conference. I thank the official for inviting me. I don't speak English, so I apologize for any pronunciation errors in English during this presentation, which is titled Nitrogen Use Efficiency and Dynamic in the sunflower wheat cropping sequence as influenced by crop residue management. I will follow this plan in my presentation. I will start with an introduction where I will highlight the context of the study and the objectives. Then I will explain the plan of experiment. I will then move to on the minor results obtained concerning the relative contribution of fertilizer nitrogen and soil nitrogen to nitrogen uptake by sunflower plants, and determination of the percentage of fertilizer nitrogen recovery in sunflower by isotopic and non-isotopic technique. Balance will start with the balance of 19N fertilizer, or isotope and 19N of fertilizer at sunflower harvest. Then in cans, pardon, sorry, 19N recovery of residual fertilizer in plant, sunflower wheat, and soil up to 0.9 meter deep. And fertilizer nitrogen balance after 4 growing season. I would end with a conclusion. Sunflower is the main oilseed species cultivated in Morocco. It has several advantages. It is economical in water, mineral and salt, and nitrogen, easy and inexpensive to produce, optimize the profitability of cereal, restructure the soil, interrupt the disease cycle, limits the development of weed. On the way with the agronomic and environmental quality, the sunflower has its place in efficient and sustainable agriculture. Despite the efforts made by all members involved in the sector, national production remains far from meeting the country's needs. Sunflower planting are well below the country's potential. National yields are also low and about 6 quintal per hectare, and these yields fluctuate widely. There are several constraints. In addition to climatic drought, economic, marketing problem, lower selling price, and technical content, broadcast soil, and selected seeds, the sector suffer from under-fertilization. 67% of farmers do not use any fertilizer. 28% provide low fertilization without reasoning. 5% only provide reasoned fertilization, such as the National Institute of Agronomic Research and certain cooperatives. On the other hand, there is a poor management of sunflower crop residue. They are rarely crushed and incorporated into the soil. The Moroccan farmers sees these practices as unnecessary economic charge. In fact, the farmers burn them or export them off the plot for domestic use. This type of agriculture with low input and without recycling crop residue leads to a decreased soil nutrient supply, which causes a decrease in the chemical and physical fertility of soil and gradual decrease in crop yields. So, better development of sunflower production in Morocco must go through to good management of fertilization. This requires a good knowledge of the dynamic of nitrogen in cultivated agro ecosystem. This is the role of research. However, the latter's intervention in this area remains very weak. Concerning the state of research in Morocco, in this subject. In fact, we installed our test when we installed our test. Sunflower fertilization was still in the development stage in Morocco. Few studies were reported on sunflower fertilization. Little information were available on the fate of nitrogen fertilizer applied to sunflower. No information was available on the fate of residual nitrogen from fertilizer in the soil during sunflower harvest. Very few studies were reported on the role of incorporation of sunflower residue on crop productivity and soil quality. The scientific objects of our study were to add a contribution to research in the field of sunflower fertilization by improving understanding of the fate in the short and medium term of fertilizer nitrogen applied to sunflower in a succession of crops, sunflower wheat, and add value to sunflower harvest residue by studying their effects on crop productivity. To aim these objects, pardon, field experiment was conducted in the irrigated condition on a vertical in semi-arid Morocco to assess the use efficiency and dynamic of nitrogen fertilizer applied to sunflower in their two sunflower residue management mode, incorporated or eliminated using isotopic technique. The experimental design was a randomized complete block with 4 treatments and 4 replicates, totalizing 60 plot of 16 meter square. For T1 and T2 treatments, for T1 and T2, fertilizer in the form of ammonium sulfate enriched with the isotopic 15N of nitrogen to 627% atomic excess was diluted in water, then it was band applied to the saline line at a total rate of 60 kilogram N per hectare. For T3, it was the same, but with not enriched fertilizer. Donc, ammonium sulfate with the N in isotope in 14, in 40 N. In plot T0 treatment, there was non-fertilized archid. I must specify that at sunflower harvest, crop 1, season 1, sunflower harvest, at sunflower harvest, the soil of the plot of T1 and T2 treatment were marked with isotope 15N, both by the sunflower roots remaining in the soil at harvest of sunflower, and by the probably residual nitrogen of 15N fertilizer in the soil. After harvest, sunflower residue of plot treatment T2 were eliminated. But sunflower residue from T1 plot which were marked with 15N or buried in marked soil of plots in treatment T3. And those from treatment T3 are buried in plot for treatment T1. The T3 treatment was used to study the nitrogen fate of marked residue during the following seasons. But this is not the subject of our presentation. No. The T0 treatment is used in the first year in order to make it possible to calculate the fertilizer nitrogen recovery in plants by the no-isotopic technique or no-isotopic technique called the difference technique. Alors, in the rest of our experience, only the T1 and T2 treatment will be compared to follow in medium term, the fate of residual fertilizer in nitrogen in the plant soil system according to the two methods of managing sunflower crop residue buried T1 in treatment T1 or eliminated in treatment T2. Three successive crops will be planted on the plots of T1 and T2 treatment, wheat, then sunflower, then wheat. Now, principal result of our experience. In this table, this table shows the relative contribution of fertilizer nitrogen and soil nitrogen to nitrogen uptake by sunflower plants. Here the value or average in two treatments T1, T2. Donc, c'est la moyenne. Average of T1 and T2 is represented in this table. Alors, in this table, this table shows NDFF, c'est-à-dire, bon, N, c'est nitrogen derived from fertilizer, percentage NDFF, percentage nitrogen derived from fertilizer, and DFS, c'est amount of nitrogen derived by plant from soil, and percentage nitrogen derived by plant from soil. These value are calculated via formula. Alors, percentage NDFF and derived from fertilizer is calculated by dividing the atomic access 15 N in the plant by the atomic excess of 50 N in the applied fertilizer and multiplying by 100. And the FF is calculated by multiplying percentage of NDFF by the total nitrogen uptake by plant and dividing by 100. NDFS in nitrogen derived from soil is equal to 100 minus percentage in nitrogen derived from fertilizer, and nitrogen derived from soil amount is calculated. Percentage in TFS is equal 100 minus percentage in TFF. In DFS is calculated by the difference between total plant uptake and NDFF. We found that only 11% of the nitrogen supply of the plant comes from the fertilizer. The plant gets most of its nitrogen from the soil, which indicates low efficiency of nitrogen used of fertilizer by sunflower. On this table, we have presented the value of the coefficient of nitrogen use, nitrogen use of the fertilizer by sunflower estimated by two techniques, isotopic or direct, and non-isotopic technique, also called indirect technique or difference technique. Donc, CRU, CRCU, c'est coefficient, réel coefficient, coefficient of use of fertilizer. ACU is apparent coefficient of use of fertilizer. CRU is determined by multiplying the total N uptake form of the plant by percentage NTFF and dividing by N dose of applied fertilizer. CAE is determined by subtracting the total N uptake of the unfertilized control from that of the fertilizer treatment and dividing by the amount of N of fertilizer applied. Value in parentheses correspond to standard deviation. The sunflower used almost a quarter of nitrogen of the applied. The result demonstrates that the sunflower used almost a quarter of the nitrogen of the applied fertilizer, and there was no significant difference between the value obtained by the two techniques. This figure shows the distribution of nitrogen of the fertilizer in the different organs of the plant, residue, seeds, and roots. It shows that most of the nitrogen of the fertilizer is found in seeds and residue. Very small parts, less than 1%, is found in the roots, but it constitutes a part of residual nitrogen in the soil after the sunflower harvest. At the first season, N recovery by sunflower was 24% by crop, 24%. Donc, sunflower was used first 24% of fertilizer applied. Donc, at the first season, a recovery by sunflower was 24. At harvest of sunflower, 50% of fertilizer N was found in the soil profile up to 90 centimeters as residual fertilizer derived N. The distribution of nitrogen fertilizer in the soil profile showed that largest fraction of this nitrogen remained in the surface area of the profile up to 30 centimeters. Approximately 14% of the nitrogen of fertilizer applied to sunflower remained in the area 30 to 60 centimeters for the profile. No more than 3% of the residual nitrogen is found in deepest zone, 60 to 90 centimeters of the profile examined. These results clearly show that the migration of nitrogen from the fertilizer into the soil profile was low, probably due to the fact that the competing process of organization by microorganisms and losses occur early and more quickly than the transfer of nitrogen in the profile. 22 to 26 T1 and T2 treatment, average 24 could not 25% could not be accounted for and was assumed to be lost for the soil plant ecosystem, primarily to road denitrification and volatilization. The low fertilizer nitrogen value in the area, 60 to 90 centimeter, indicates that the leaching losses which probably occurred during the sunflower growing season were not too great in the condition of our experimentation. Now we will follow the recovery of 19N residual of, in soil by the recovery by plants, tree plants in succession. Our of the residual 19N labeled fertilizer, the three successive crop recovered respectively 1.7, 3.5, and 1.5 in plot T1 treatment with residue, and 1.9, 3.6, and 1.1 in the treatment without residue. The addition of crop residue did not have a significant effect on the nitrogen use of the residual 19N labeled fertilizer by wheat and sunflower grown in the first 2 seasons after incorporation of residue, wheat and sunflower. This is sunflower in season 1. The residue of this sunflower were buried in the plots and were sown with by wheat. So wheat and sunflower in the 2 season, after incorporation of residue, it was no significant effect. On the other hand, the nitrogen used by the 4th crop were significantly improved by up to 23% with addition of residue. This resulted among the first to show that residual effects of crop residue are prolonged and probably result from changes in the soil property that enhance soil nutrient availability. The recoveries of 90N residual fertilizer in 19N residual fertilizer in the soil were important, and soil recoveries were higher in plots with residue than in those without residue. However, this improvement was only significant in the 4th season, suggesting that the effect of burial of sunflower residue is not immediate. We drew up the nitrogen balance of the fertilizer at the harvest of 4th crop season, which result are represented in this figure. It showed that the addition of residue increased the amount of fertilizer retained by soil. By soil, yeah, it is demonstrated in increase of the amount of fertilizer retained by soil, donc about 60 kg in hectare per hectare of fertilizer applied. 21 were in soil, were recovered in soil in treatment with residue. 16 kilograms were retained in soil without residue. which corresponds to an improvement of 30%. However, burying the residue makes it possible to reduce losses. Losses are reduced in treatment with residue compared to treatment without residue. Donc, burying residue reduce the losses of residual and nitrogen of fertilizer outside the plant soil system. In conclusion, our study has demonstrated that the nitrogen fertilizer used by sunflower plants is low. To assess the efficiency of nitrogen fertilizer used with sunflower, the difference method, simpler and less expensive, is sufficient. About 25% of the nitrogen of the fertilizer applied to sunflower is lost out of the plant soil system and may pose a risk of environmental pollution. Residual nitrogen at sunflower harvest undergoes slow but gradual remediation, such as residual effect could store nitrogen in the soil, thus increasing the availability of nitrogen for subsequent crops. The burial of residue is an action to recommend since they reduce in fertilizer losses from plant soil system and enhance soil nutrient availability. After 4 plant cycles, 25 to 36% of initial intake was still present in soil, suggesting a longer-term effect of single application of fertilizer. Thank you for your attention. Je m'excuse pour la prononciation.
Thanks a lot for your presentation, Dr. Nabila. So, do we have any questions?
Please, in French.
Do we have any questions? Just give me a second. I'm sorry for the disturbance. Just give me a second. I'm so sorry for the disturbance. So yeah, do we have any questions? I guess there are no questions. So anyways, thanks a lot for your presentation, Dr. Nabila, and you have tried a lot to do this presentation. I appreciate your efforts for this. Thank you so much.
Thank you very much.
Yeah. So with this presentation, we have come to the end of our webinar today. And I thank each and every one of you for your presentation, for your presence and all your patience and making this a successful one. Thank you so much. And we would love to hear from you about your feedback towards the webinar. And also we do have our next webinar being organized in the month of March 28th and 29th, and I really wish you all to attend the same, and we'll also send you an email with all the details once again. And regarding your certificates, you will receive your certificates, the conference book. I hope you have already received it, but yeah, you'll receive it once again with the next half an hour. And please do check your emails. And thanks a lot once again for your presence and all your presentations. Every presentation was informative. Thank you so much. And we would love to hear your feedback through email. Thank you so much.
Thank you.
And if you're having any questions, kindly do let me know and I'll be available here. Thank you.